So hi friends, and today we shall be discussing about the recommender system in Python, and this is a very basic recommender system which we will build today. So this is the website. I would be providing the link so you can go through this in detail. So what is a recommender system? I'll just walk you through in very brief lines that it is just it can be understood as when we make suggestions about a movie, we have our own opinions, and suppose our friends ask us that how was the movie, did you like it, and based on our opinion they judge whether to go or not to go. So this recommender system is such a system which also gives you some recommendations, and based on it you decide whether you want that movie or you want to go for that show or not. So we have seen a classic example of movie recommender or any shows recommender, and that is Netflix. So that is the classic example for this. So there are various recommendation systems, but most common are like collaborative and content based filtering. So in this recommender system, in this project, we will just be building a simple recommender system, and in the next we can see about content based filtering. So this is the theory part. I hope this page will guide you through, walk you through this process, entire process of random and popularity based, item based, systems configuration, content based system, collaborative filtering, and all. So I'll just walk you through the data set. So what you do is you go to the Kaggle website, and here you would find this TMBD 5000 movies dataset, and you can just download this dataset from here. Two dataset would be downloaded, two files, CSV files. One is credit and another one is movies. So you download them, unzip the zip folder, and start building your recommender project with me now. So now, okay, we come to our directory where we'll be working. So I'll just zoom in. So this is my current directory, and I have uploaded the files here. This is credit.csv. I have uploaded this file. So wherever you've downloaded that, upload the file credit.csv, and another one is movies.csv. Now what we do is my file is already running, so I'll just walk you through this file, the code of this. So okay. So we start with importing the basic libraries, that is NumPy and Pandas. And the second step is download the dataset. Now we load the dataset here in this Jupyter notebook. And how do we do it? We create two objects. First is df1, and in this we read the CSV file. The first is like credits.csv. You can also rename this file as per your choice, right? And then you see the first 5 entries of this df1 data frame, and we see that we've got 4 columns: movie ID, title, cast, and crew, as you can see it here. And now we see the shape of this data set. We have got 4803 rows and 4 columns. If you see the information of this, it will give you the null values and the data type and also the columns. So we have seen that there are no null values here, and the data type is integer and object. Okay, right. So now what we do is we load the data set for the second data frame, that is the movies data set, convert it into a data frame, and we see the first 5 entries of this data frame 2, and this is the movies.csv file, right? So you can see that how this has been here. So I just show you an entire field of this: budget, homepage, ID, keywords, and so on. If you just go on with this, vote average, vote count, just see this: vote average, vote count, tagline, and runtime, revenue, release date, so production company, production countries. This is the data set. Now what is the shape of this data? I see the shape of the second data set, and that is 4803 and 20 columns. That means 4803 rows and 20 columns. Information, if we quickly just derive the information of this, we see that there are some, you can just see the column names and the none values, and in home page we've got some null values, okay, and rest we don't have, but here in taglines also we've got certain null values to deal with. So right now it is not of a concern, but we'll move on to a different thing. Now another thing is that now you have to merge this data set to proceed further. So what we'll do is we will merge the two data frames, okay. So I will merge these two data frames on the column ID, okay, because this is the same on both the data sets. So what I do is in df.columns, this is the object in which I will have four columns, that is ID, title, cast and crew. That is what our data set had. And on df2 I'll create an object. In this I will merge df1 on what? ID. Simple, right? And you check this df2.head, that is, it will give you the first 5 entities. And when you will see this, you can see that you've got 5 rows and 23 columns. Okay, that means your 4 columns have been increased. Last 3 columns, if you see here, that is the title, cast and crew, which was our first data set. So this has been concatenated or merged. Now we come to, now another thing which I want to show you is something here, which I'll come here. Now let us just understand what I'm doing here. Now we want to dig into this data set and derive some meaningful information from this. So for this, what I have to do is I want to find some metric for rating the movie, because I have to rate the movie, and as per its good rating I will recommend that movie. Okay, if it is a good movie it will have high rating and vice versa. So now we need to calculate the score also for every movie so that it can be easily analyzed, right? And also we have to sort the scores, and you can then recommend the best rated movie to the users. So this is how we go to it. Now we will have to find the scores, and we have to find a metric wherein we can rate these movies, right? Now the simplest thing would be, we have a column called average. Okay, if you see here, we've got a column called average rating here, vote average. We could simply use this column to make recommendation, but the thing is that your count differs. Now suppose this movie has a rating of 7.2 and the vote count is lesser than the movie which has got 6.9. So this would not be justified. That means vote average, if it is greater but vote count is less, then the movie recommendation would not be justified. Okay, so what I do is I go with this IMD's weighted rating formula, wherein this weighted, as you can see this, that you have this number of votes divided by number of votes plus minimum votes into the average of rating of the movie plus the minimum number of votes divided by, again, V plus M into C. C is the mean of the vote across the whole data set we have, right? So this is the formula we will be using for this. Okay, this formula. Now we'll go back to our data set here, the Jupyter notebook, and we will see how do we calculate this C. So I create an object called C. You can name it anything, but as per the formula, for the convenience, we are writing C. So C is equals to what? What do I want for this data set, df2 data set of vote average dot mean. Since I have the vote average, I will take out the mean of it, the entire columns, the entire 4803 columns and rows, and we will find the mean of it, and the mean is coming to be 6.09. That means roughly all the movies are rated, like on a scale of 10, they are rated on this as 6. That is the mean average. Okay, but now how would you recommend these movies to any user, that which movie is the best or popular? So what we do is we find the minimum votes so that we can eliminate few movies from our chart, okay, or from our list. So what I do, I create an object called M again. So this for the calculation sake, take a variable called M, and again vote count, and we'll take 90, quartile 90. Why we are taking this quartile 90 is that because of the 90%. We want 90th percentile of our cutoff. That means that the movies which have votes more than at least 90%, they will be in the list. Okay, so I want the movies, only those movies which have got higher vote, and I want them to be included in this list. So that's why I'm giving a quartile as 90. Okay, so I'm giving this quartile as 0.9, and when you find that 1838 something movies, this is the minimum values, which means that this is the minimum value which I can include in my list. Now I will put these two values in the formula to get the list of the movies which would be made for recommendation. Okay, so what I do is I create an object called list underscore movies. You can create any object, any name, and then make a copy of your df2 data frame 2, and then you just create a condition here that vote in this column vote count, if it is greater than equal to m, that means if this minimum value, this minimum vote is greater than equal to 1838.40, then include that movie in that list. So that is what it is doing. It will include 481 movies. When I see the shape, it will include 481 movies in the list. Okay, so I've got my new list of movies. That means the highest rated movies as per the formula, right? And this is not based on any assumption, any assumption like any average or any vote kind of thing. We have calculated it with a formula. Now what we do is, now we have to get this thing in our data set, in this table. So what we do is we define a function, and this function is weighted average function, this weighted rating function, and in this x would be like every movie, and m equals to m, same, the minimum votes. C will be the mean of the entire movie, right? Average, vote average. And create these v and r because these will be needed in this formula. So this v would be vote count and r would be vote average. Okay, so this is what we have dealt with this in this formula. If you remember here, that v is the number of votes and r is the average rating, and that is what we have used here in the formula. And then you return this formula as v divided by v plus m and so on. Okay, now here again for your reference, m is 8318.1838 and c is 6.09. Okay, now again moving further, what we do is in this list movies score, this is the column which I want score here to be added, and where you apply what? You apply this weighted rating and axis is 1, that is in this column it would be added. So now when you see this head, you see this data frame head movies list, you will find the score being added here. See, this score has been added here, and how have we calculated this score is through this weighted rating. Okay, right. So now you can also see the shape of this. If you don't want to see this thing, you can just see the shape and you see it is 24. That means another column has been added, and that is of the score. That is what we wanted. Now since we have all this entire data, entire rows and columns, now we will sort these movies. Okay, we sort these movies according to their score so that it is easier for us to understand which movie ranks the first. Okay, so now we again go on this object list movies which we have created earlier, and then we will apply the sort values, and ascending is false. Okay, so the highest movie rating would be coming here. So now I just see the first 10 movies, and what all columns do I need for that? I have taken title X, I have taken vote count, average and score. So you can take other features, other columns also if you need, but these are the important ones, so I have taken that. And you can see that the movies listed as per their score in descending order. Okay, Godfather, Inception, Pulp Fiction, Dark Knight. So if you've not watched this movie, Shockswang Redemption, if I'm not wrong, yeah, Shockswang. This is a very nice movie, you know. You should watch this movie. Godfather, Inception movie. The novel is better, I feel. Mario Puzo's Godfather. Okay, so these are the movies which are being ranked according to their score. Lord of the Rings and stuff. So now this is the basic, I would say, recommender system, but there's one more step to this. It is that the most popular movies. Now what happens is that if you want to go and on some tab in some website, and you see the trending movies tab and you see the most popular movies, the scroll down list will come. Okay, so how do we get that? What you do is you make an object called pop, and in that I go with the popularity. This is a column, one of the column in my data set. If you have not gone through, I will just show you this column. So according to popularity, I will be seeing my movies. Okay, so I'll just show you this popularity. Where is this popularity? Yeah, here, the popularity. According to the popularity, I want the movies to be listed so that I can select which is the most popular movie. That is what I want. So what I do is, here I come, I sort, and again I see the 6 top most popular movies here, and this is just going into the nitty-gritties of plotting the matplotlib horizontal bar graph. So you can see it in I'll be providing this code, no problem, just understand this code. So we've given the title, we've labeled the x and y axis, and as per the popularity we are getting these movies. So you can see Minions is the most popular here, Interstellar, Deadpool, Guardians of the Galaxy, and so on. I am getting 6. You can just change this to 10 or so, right? Now another thing, you can just play around with this feature. Okay, instead of popularity, I have just used here like budget. So the high budget movies, it was Pirates of Caribbean, On the Strange Tide. So you can see here. And next was again Pirates of Caribbean, then Avengers, Superman Returns, John Carter, and so on. So you can also change this, like change this to 10, 15 as per your choice and recommendation. Okay. So this is about how do you really sort out the movies as per their budget or popularity or revenue. So if you want to see about revenue, you can see this, and I can just change the color if it is running. Okay, so this is about the revenue, and you can see that Avatar was the movie which had the highest revenue, then Titanic, then Avengers, Jurassic World, Furious 7, and so on. Okay, so if we just see here, like 10, okay, single shape. All right, let's revert it back. Yeah, so this was on revenue. You can experiment with different features here as per your choice. So this was based on the popular movies, on the budget, and on the revenue. Another thing, if you explore in this columns, I would just walk you through these columns. Like you can go ahead with the runtime also and see the movie's runtime, which is the highest rated movie in runtime. And now this variable has to be like something in numeric. Okay, so try experimenting with that and see what comes out with different plots and colors. So this was it for this video, and in the next we shall be dealing with one more thing, is that this recommender system is not that robust, because it is not giving you your individual taste and preferences choice. It is just giving you a basic general, I would say, movies, right? It is not giving you any content based filtered, like according to your taste, according to your, like if you have selected thriller or horror or mysterious movies, it will not give you those movies. It will give you the most popular, most sought after. So to make it more content based, more user preference based, we have to make content based filtering into this recommender system. So we will, in the next video, we shall dwell more into the depth of this recommender system, and we'll deploy this content based recommender system into this the same movie recommender system. So that would be the second follow-up or the second part of this recommender system. So stay tuned for this video, guys, and thanks for watching. So welcome, friends, and this is the part 2 of our movie recommender system, and we will be doing content based recommender system today on the same dataset, TMBD DB 5000 movies dataset. Okay, so let me just bring into picture what is this content based mean. So content based simply means your description, whatever description you have of the data or the movie or any item, you take that as content, and based on that description the recommendations are made. Simple as that. Now for example, I've given this example, like suppose Jane likes Terminator. So based on this preference, the other movies will be recommended, other science fiction like Alien and Predator. So this is how this recommender system works. Now here it is like what becomes the training data and what has been predicted. So the thing is that these item descriptions along with the ratings are becoming our training data, and this is specific to a particular user. Okay, and the dependent variable is the specified rating or the buying behavior. Now, one thing to note here is that either you make any classification or regression model, and this is specific to a user. Now, things will become more clear. Just be patient and stay with me in this entire video because it is both practical and theory based. So we have much in theory here to cover. So the advantages and disadvantages, I think you can go through this from this site. I will provide the link. But the thing is that I'll just brief you that these recommender system content base is the advantage is that even if you've got few items and with no history or no rating history, then also you can get few recommendations. Okay, and when you're making recommendations on new items, when sufficient rating data is also not available, then also you can make recommendations. So A, you're not having sufficient data, you can make recommendation. B, you don't have much history about any particular item, then also you can still make recommendation. But the disadvantage is that the new user for new user you cannot make recommendation because any data is not being collected. The new data new data is not being collected from this new user. No history is being recorded for this new user. Another thing is that the recommendations are based on your own choices and preferences. So your choices become narrowed down and the community view is being ignored here. So collaborative filtering, as we see that collaborative based recommender system comes into picture here when you also get the community view. So now, okay, let's get started with our movie recommender system. So I left it the previous data set over here, our project, and I'm working on the same directory with my same movie recommender Python file. So I just see when I just explored my data set, I discovered that this title was redundant. So I dropped this title Y, which was same as title X. So you can also drop it if you have it, or if you've previously done it, then that's good. So your shape should be like the object should be like 481 rows and 23 columns, right? We have just dropped the redundant title. So if I just show you how does our data set look, so this is what we have. That is the budget, genre, homepage, ID, keywords, and we have concatenated the two data sets, cast, crew, and score, right? Okay. So now we come to the overview column, if I'll tell you. So this content based, how will I make this content based recommendation? I will use the column overview here. This overview is nothing but description of the movies, like Avatar, the movie and its description, Pirates of Caribbean movie and its description. Based on this description, I will find out how the movies are similar to each other and I will make the recommendations. Okay? Okay. So this is the overview column and I will see this overview column and the top 10 entries of it. So this is how I get the top 10 entries of it. And you can see that in the 22nd century, this was blah, 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 Captain Barbossa, cryptic message, and so on. Now, we've got this description. Okay. Now, based on this description, we are making recommendations and we have to understand the similarity between these descriptions. Now, there are several plots, or I can say several descriptions of these movies. Now, how do we do this? Now, this is some theory part. Please stay with me with this. Before going on to explain you this TF-IDF vectorizer, let us first understand this word to vector. What does it do? We will be using TF-IDF from sklearn, but what is this word to vector? This is simply, I am converting. Imagine this thing now. I want you to wear your thinking hats and just imagine this with me, that this is a three-dimensional space and I've got all the movie description and I want to just scatter these words all across the space. Okay, and based on the similarity, you will just place these words together. This is what we are doing with this word to vector. I am giving my each word a magnitude and a direction. That is what vector stands for, right? This is having both a magnitude and a direction. So that's what I give. For example, I give this walking in walk. I give it a direction and a magnitude, and that is how you can just map that they are similar, and this is how the similarity is being mapped. Now suppose you've got thousands and millions of words and they will be scattered here, and you can find it out through some similarity. This is how you can visualize this and really make analysis and data visualization of these text. It becomes really simple. Okay, right. So now what we will be using is TF-IDF. Now here come the drill. I'm using two terms here, term frequency and also inverse document frequency. I'm using both these terms here. So first, to understand the term frequency. See, you can go through this paragraph here. I'm not going through this. This is definition. So this term frequency, it means that the number of times a particular term appear in a document. Okay, and so I have just explained you with the help of an example that this T is a word, is the term which has been appearing in the document, and how do I calculate this frequency is by number of times this T terms appear divided by total number of terms in the document. Okay, yeah, this is how you calculate the relative frequency or the frequency. Now you come to this inverse document frequency. This is computed by taking the log of it. Okay, now to put it simply, I would simply say that this inverse frequency is, where has it gone? I'm just searching it. That term frequency, this measures how frequently a term is occurring, whereas this inverse, I would say IDF, document frequency, measures how important a term is in the document. Okay, so what happens here is that there are several terms, like millions of terms or thousands of terms, and there will be certain terms like stop words, add, the, etc., which are not so important, but they are given importance and significance. So what we do is we reduce their significance by using this IDF. Okay, and this will give you a measure of how important a term is in your document. So this is the formula. You can go through the formula, the log of it, and we will be using this formula in our data set here. So let's just go and see what we do this. Now before that, I will just tell you that we don't have to go into nitty-gritties of it, because in sklearn Python library, we already have this TF-ID vectorizer, which will do things, make things easier for us, right? It will make a matrix for us, and we'll see how our words are being plotted in this matrix. So what we do is we define a vectorizer object and we remove these stop words. That is what we are doing. We remove these words, stop words equals to English, and we've got certain, empty or NaN values here. So we will replace it with an empty string, okay, fill NA, and we will construct a matrix, and we will fit and transform this overview in this matrix. And when you print the shape of it, you will find that there are 4,803 rows, that means the movies, and some 20,978 words, which make the entire description of these movies. Okay, now we've got these matrix which has been plotted in this space just like this. Okay, now what we do is we will find the similarity. Still the similarity is not being calculated. Okay guys, so what we do is we will use some linear kernel here, since we are using the cosine similarity here. Now the thing is that which similarity score to use or metrics to use, it depends on you. You can use either Euclidean or Pearson coefficient or anything, Pearson's, or different matrices available, but we will use cosine similarity because if it's convenience to use, it's fast, it's easy, and this is independent of magnitude. So the formula also, let's see the formula. And why am I using this linear kernel? Because it is also fast here. That's why I'm using it here. And so we use it, and we, again, from sklearn, we have imported this linear kernel, and then we compute this cosine similarity matrix. And this is how you write it. Run this, and then we will define a function, and also I will tell you what are we doing here by duplicating and mapping it. So now what you do is we are defining a function, and we will do a reverse mapping of movies, titles, and the data frame indices. Why? Because we want to identify the index of the movies in our metadata. That's why we are doing this thing. Okay, and we will also drop the duplicates, because duplicates will be formed when we do the mapping of it. So This is how we are linking things. And now you define the function. Now in this function, what will happen? It will take an input of the movie which we give, and it will return 10 similar movies, okay, based on the cosine similarities. And this cosine similarity we have already calculated here. We'll take that here, make this block, and in this block we will define few things now, okay. So we will define the index here. So we get the index of the movie that matches the title. We will get the pairwise similarity scores of all the movies, right? We will sort these movies on the similarity score. And here I have used the function, anonymous function lambda here. This will take this x, but it will return what? The first element of x, okay? And then I will take the score of the 10 most similar movies and get the movie index, and then return the top 10 similar movies. This is how you will run your entire function. Then you can just simply use this function here, get recommendations, and when I run this, The Dark Knight Rises, I get the top 10 movies based on this movie similarity, especially the plot of it, especially the overview of it, right? I'm not using any other feature apart from just overview. Now I'm getting this Dark Knight, Batman Forever, etc. Similarly, you can make recommendations for different movies, JFK and etc. Like you can use Avatar, The Matrix. Now, I'm coming to one point. Still, there is flaw in this recommendation system. Not flaw actually, but it can be further improved. Now, suppose I want the movies of the actor or the cast of The Matrix, Keanu Reeves, okay, Keanu Reeves, movies like Point Break, Speed, John Wick, in which he was the cast. But my recommendation system is not giving me the movies of my actor which I like. Rather, it is also giving me the movies like, Transcendence and I don't know what all. Right? Now, suppose I don't want to watch the movies of Iron Man or, The Dark Knight Rises of Christopher Nolan. I want to see the similar movies of a different actor. How would I get those movies? So there's a flaw in this recommender system, that it is not giving the movies or as per the crew, cast, or the genre, or the keywords, the director, anything, right? So I can make it more and more robust by including different features in it, by including my cast and crew. So that would be a different project altogether. I mean, different coding altogether in this. Okay friends, so today we are with the content based recommender system. This is on demand video. This is the part 3 which we will be building, and this is the recommender system based on keywords, crew, cast, and genre. Yeah, genre, and this is how we pronounce it. Okay, so before you start this video, make sure that you have seen the part 1 and part 2 of this recommender system, which I'm working with the same CSV file, that is credit.csv, and you can get this file from going on this dataset like tmbd of here. You can go and access this file on Kaggle tmbd dataset, wherein you will also get the CSV file which we are working, credits.csv, and another file is movies.csv. So I'll just show you how does this look. So have a quick review of this. In the first file we have got some around 4 columns and 4,000 something rows, and in the second movies.csv we've got certain around like 4,000 rows and 20 columns, and I have just merged it also in df2. Okay, and I'll be working with this df2. So I have merged this on id, and so that I can get the title, cast, crew as in a single data frame. Okay, so please make sure that you go in and watch the previous videos of movie recommender system part 1 and 2. Links will be provided also in the end card. You can see that, right? Okay, so assuming that you've gone through how we have built a recommender system based on the overview, that is the most popular movies in the overview column, and I am also assuming that you know how to work with like what is the difference between like why are we using this cosine similarity, and how we have really trained the model and fit all these things and transformed
We have used this TF-ID vectorizer, right, so that we can count the frequencies, and we have used actually inverse TF-ID. So not investing much time in that, I would just simply go on to this video. So what we did was had used only the overview column to make recommendations. The overview only meant that you have the similar plot. So Dark Knight Rises have the same plot as the Batman Forever, similar plot, so this recommendation were based on the description, the similar plot. So I just got the first 10 recommendations on the movies like JFK if I want to watch. So these are the recommendations. Now what we want is we want to further upgrade our content based system, recommender system, so that we can get movies as per the cast or the keywords or the crew, like the director or editor or the genre. So what I do is now I have to use the literal evaluate for this. Now before I jump into and explain you why are we doing this, you first need to see the data set. Okay, so I will just show you the data, the unclean data which we were working previously, because I have not disturbed this file, I just kept it like that. Now can you see this keyword? You have this in a form of a dictionary, and you've got various things here, keyword ID 1463, then you've got some colons, semicolons. So there's a lot of error when you parse this data, these columns and rows. Even in the genre you have got this, you've got it in keywords, you've also got it in the cast, but I have to use this cast. Now to make things more simpler for you, I will take you to the data set itself and show you how does this look. This is the cast. Can you see? This is huge. This is long. Can you see this? Okay. So now I will take you to, all right, this is the cast of Avatar. And can you see this is quite long? Now what I want is I just want to clean this data. Okay, that's what I'm doing it here. So what I'm using here is, okay, just bear with me when I just scroll these things. I'll just stop where we are doing it. So now what I do is I use this literal evaluate, right? From AST I will use that so that I can clean my data and I get a very simplified list. So that is what I'm doing. I'm creating a list of list name features. In this I am just storing this cast, crew, keywords and genre because I'm using this thing. Okay, you can also use like cast, crew, keywords if you don't want genre. You can also use cast and crew, depends upon how do you do it. So I just wanted to make it more diverse, so I use these four columns. Okay, right. Now I create a for loop. In that what I do is I just use these features and I apply these literal values, and it will go and iterate in all these the columns and will really make it very simple for us. So if I just can show you a little bit about this. So this is the website. I'll provide the link in the description box. Do not worry about that. You will get it. So this is what happens here, that you've got this ID, and what happens is that you get it clean, as you can see here, only in the form of a list. That's what we are making it. Now what we do is I have not written here because it is being written in the website. It would be redundant. Now what you do is you make a function. So now we'll make 2-3 functions so that things will be more clear. What I'm doing is I'm just using the director's name from the crew feature. Now in this, why only director's name? Because in this crew you've got various names, like under the job you've got director, you've got editor, you've got screenplayer. So I'll show you how does this look. First understand the data which you're working in. This is, I think, cast and crew. Okay, this is the crew data which I was talking about. Now you see you have this as department, the key, it is in the dictionary format, right? So the key and the value. Now you see here the key is job and it is editor. You've also got one as, now if I show you this one, cast, and you see this job as, okay, fine, director of photography. You've also got only director, right? Yeah, you can see original music composer. There are various jobs. I just want director. I don't want all these things. Okay, that's why I have, see, you've got screenplay also. What I want is I just want director. Okay, so I have used this as a function, and in that I'm saying that I just want a list of directors, so please give me that, and you return np.nan if you do not find any director in that list. Okay. Next, now if you're not fascinated with direction, if you want some specific thing, you can mention here. Okay, depends on what you want from the data, what value you want to extract. Next thing is, what I do is, now since I also have to use like cast, crew and keyword, now I will extract all crucial information from these three columns. What would I do is, okay, sorry, crew is done, cast, keyword and genre. So I will use a single function for all these things. Now I will make a function called get list. Okay, and then I will go in for if and condition. Why I am using this condition? Understand the logic, you can get the code. Okay, I will provide the GitHub link also, and it is also uploaded on the website. Now and again I will go walk you through this data set of cast, crew, so that you understand this thing. What I do is, now you can see this genre. Okay, now I have, as you see here, name. It is action, it is also adventure, and it is also fantasy and science fiction. Can you see this? Okay. Next, if I explore, it is adventure, fantasy, action. Next, it is action, adventure, crime. So I've got various genre. The nature of the movies, they are of different types. Now, this was genre. Now I will take you to the keyword of it. The keyword is culture, clash, future, space war, space colony, society. I think it is Avatar. Okay. All right. And then you've got ocean. Okay, where is it? And then you've got this ocean, drug abuse, exotic island. This is Pirates of Caribbean. Since I've done it so many times, I also remember the name. Like, see, Avatar, Pirates of Caribbean. Okay. So you can just understand from the keywords also which movie is there. Ocean, drug abuse, exotic island. So if you want to watch a movie on oceans, you can just give it the keyword and the movies would be retrieved, right? The second keyword is spy, based on novel, secret agent, sequel and stuff like that. Now you understand that how we have got the data, and now we have to extract these keywords from this, and that's why we are making a function with a condition. Okay. Let me also tell you one more thing which we are using, and that is, I think, okay, we're using genre, keyword and cast. So the cast is, since I have not merged it here, I can tell you the cast here. Now can you see this cast? It's Jake. Okay, then you've got Sam, and you've got Kelson, Dragon, Gunship, Gunner. I don't know what all cast you have. Then again you've got Captain Jack Sparrow, then you've got Johnny Depp. There's so many cast here. Okay, so as you can see here, there's so many cast, right? I cannot use all the cast here, so what I do is I will use only the main cast. Okay, so that is how I'm extracting the data from this, and so that is the function to extract the meaningful data from this. So what I do is I create a list of this. Again, I use if is instance. If it is present in that list, then you return that. And another condition is that if the length of name is greater than 3, then you return me only 3. Okay, 3, that means if the cast is, if I've shown you the genre of this, or okay, if I've shown you the, okay, I'll show you the genre. If I have shown you this thing, then only 3 will be returned. That is action, adventure and fantasy. That is what I want. If the length is greater than 3, it will return only 3. If it is greater, if it is 3, then it will return me 3. That is what the function says. Similarly, this will be applied to all these columns like keywords, genre and the cast. Okay, now I have made this function. Now I want to apply this function. Okay, and what I do is I will define this director, cast, genre and keywords into a suitable format. So how would I do it? I just made this df2 director, and in that in this column, what I want is I want to apply this director which I have created here, this function get director. Okay, only the directors would be concatenated here, as you can see. Okay, and what I do is, for the features, I create another column for features, wherein I would get this cast, keyword and genre, the other 3 filters, and I would apply get list, my next function in this. Okay, so when I just call this, when I want to see the first 5 entries, I can see the title, I can see the cast. You can see here how clean is this list with no dictionary format, key value, or with semicolon, colons, and different things which could have hindered and thrown a lot of errors. So we get here cast, director, keywords, genre in a very clean format, right? And so now the search would be really easy for us. That is why we have to invest a lot of time in cleaning the data. Okay. Now what you do is, again, we have to clean a data, because now it is quite possible that the same cast, that means the actors might have the same first name and the last name might differ, but you want like the name of your particular actor, like Johnny Depp. You've also got many actors with the name Johnny with different second name. So what happens here is that we will clean this data. Again, I will create a function for that, right? And in that, what we'll do is we will replace this thing capital caps lock, the first uppercase with the lowercase, and also the strings, any spaces in the string would be removed. Okay. And why am I doing it? Because when I will be using the similarity or the cosine similarity, these will not be the same name will be treated as differently. That means Johnny Depp and another Johnny would be taken as a separate actor. Okay, they won't be confused with. So now what I do is I will create this function clean data, and then I create an if else. And for the first thing, I will replace the uppercase with the lowercase, and in the second one, I'm just replacing the empty string, that is the space, with simple this thing. Okay, so that there's no space in the string. That's what I'm doing it here. Then what I do is I will apply this clean data function. Again, I did the same thing. In this feature, in this list, the four columns which I have taken, I will just apply this data, clean data, the function. And when it has been applied, what I do is, okay, I just want to show you something more here. Extracting information has been done, cleaning the data has been done. Now we are coming to creating a metadata. We have just done a lot of work here. So, okay, this would not work. So now we are just creating the metadata here. What do you mean by metadata here is that I will use this metadata in extracting the information. That means for the content base, I need this metadata. So I create some function called soup here. In this, I will just join my keyword. Okay, I will join the cast, director, and genre here. Right now, this metadata will help me to extract or make recommendations, and that is what I'm doing here with this metadata. I just define a function and I apply this in this column, in this row, right? Df soup, and here what I apply it. Now after making this metadata, what I do is I will use the count vectorizer instead of ifd. Previously we have used tfid, inverse tfid. Now I am just using count vectorizer. Now there's a difference between the two. I hope you can go ahead with the difference, but just to give you a basic intuitive knowledge about it, count vectorizer will simply count the number of times the actor has acted in a movie, which is fine for me if it is 1 or 2 or 3, and I don't have to devalue if the actor has acted just once or twice, right? So what I'm doing here is that the presence of actor, I will not downweight. I just need the count, that's all. And what the tfid was doing is it penalizes them if it if it occurs for the most of the time, because it is also considering the overall document weightage, and it gives equal weightage to the word. So that is what not we are looking for here. We are just looking for the occurrences. So that is what I'm doing here. So we use this count vectorizer here, and what you do is you stop word, again you count the stop words, and then I will create a matrix called count matrix here, and fit transform this df to soup, this one what we have applied it here. Okay, the entire metadata will be concatenated or transfitted here, right? So that we can use this count matrix for our cosine similarity. Now we will again do the same thing which we did in the previous content building, this thing recommender system. We have imported this cosine similarity, and cosine similarity 2, I'll make an object wherein I will store this count matrix and count matrix again. And now see, this thing has been done previously. I've explained you in the previous videos also, so I'll just go through it in a little faster. And if you have a problem, please do comment in the description box that you've not understood. I will try to make you understand then. Then what you do is you reset the index in the data frame and you construct reverse mapping as before. That's what we've done. I'm just repeating those steps, right? So just do the same thing. You reset the index, and what you do is index would be the title X, and then we will start making the recommendations. Okay, so I will make recommendations. I think this is just the last part of it. Make recommendations based on what we have made on the cosine similarity. I will be using this cosine similarity to object so that it just maps in all these genre and our soup and give us a recommendation based on more data that we have made available through the recommender system. Now suppose I give the recommendation of JFK movie and I use this cosine similarity, and now you see the first 10 recommendations what it is giving me: the Zero Dark Thirsty, Criminal, and so on. Okay, you just name your movie and get the recommendations. Now this I also want to show you one difference in this. When you're seeing this JFK here, you see the movies that has been recommended based on a few parameters, and that those parameters are, as you know, that is crew, that means the director. Okay, so I'll just write the director. It is the cast, that is the actors. It is also the genre, right, and also the keywords. So these recommendations are made based on all these four things that we have made, and that's what we were doing since the previous part. So I'm getting the recommendations based on these metadata. Okay, right. Now the next movie I want is like Godfather, the similar movies based on all these things. This will give me Godfather part 2, part 1, part 3, part 2, and so on. Now I just want to show you one more thing. Just see this Avatar movie. Okay, and you see here Clash of Titan, The Mummy, The Monkey King 2. And I would want you to show you the difference here. Why I'm taking so much of time here is that because I want to show you here the movie Avatar, and based on the overview which we have done it in the previous video, it was when I made the recommendation of Avatar, it was giving me different movies like Apollo 18, The American, The Matrix, and so on. But here it is completely different. When I make recommendation with Avatar here, it is the Clash of Titans, The Mummy. So based on your content, based on your search you are getting different movies. Okay, so this is the difference when you are playing with different keywords, playing with different columns. Now one more thing which you can add is the production. Now suppose if I'm more fond of Warner Brothers or Walt Disney, so what I do is I have this a column called production companies here, the production companies, and you can see here that you've got Columbia Pictures. Now suppose I want all the movies from Columbia Pictures. What I can do is, again, I can define a function and I can use this production companies and I can create a condition. If it is from Columbia Pictures or it is from Walt Disney, then you return, right? Just like I did in the case of director. I will do the same thing here for production company. So you can play around with different columns and different features to make your own recommender system. So this was the third part of the recommender system, guys. Do not get confused. It is very easy. I will provide all the code and everything. You don't have to worry. Just understand the concept, what we are doing here. This is the third part, and another one is the collaborative filtering based movie recommender system. So if you want that, just mention it in the comment section that you want the part 4, the collaborative filtering, so that I can come up with it. It might take a few days, but yes, I can come up with that. Bear with me, and if you have not subscribed the channel, guys, please do subscribe, like, and comment. And I hope you would really benefit from this recommender system, because they are really very interesting to work on, provided you understand the data, because the data is very complex. As you can see, you've got some 4,000 rows and columns, and the data is very unclean. You have to clean the data, and the basic I have already provided you. Okay, how do you do it, how do you remove the literals and make it really clean. So this will really help you in moving ahead. So today we shall be discussing about what is web scraping, the applications of web scraping, and how with the help of web scraping you can really earn money. So let's start with what is web scraping. Now this simply means that you want to extract certain information from internet and use it to produce certain outcomes or to earn money or to generate leads. So extraction of information from internet is called web scraping. Now coming on to the applications of web scraping. Now there are various applications. The first one is business decisions. Now you can make crucial decisions with the help of the data that you have. Now data is power in today's century. What happens is that when you got the data, here the example is I've taken is for the stock prices. Now when you're analyzing the trends in the stock market, you will understand where to make investment, whether the market is bullish or bearish, whether you want to buy some shares or you want to sell your shares. So this is what the important decisions about investment you can make with the help of the data. If you have that data, you can make that business decisions. Now the second one is somewhere I'll come to lead generation, wherein you can also make money with this lead generation if you know how to use it. Now, if you are suppose extracting information from yellow pages and you are creating leads with the help of these information and you sell this data, you sell these contacts or these information to companies and you save their time, you save their effort and energy just by providing leads, and this leads means sales and sales means revenue to the company. So indirectly you are adding revenue to that company. So lead generation is a way wherein you can really make money from data extraction, or I would say scraping, right? Okay, the third one is product analysis. Now, product analysis simply means that I scrape the information of the products and I derive useful or crucial insights from that. How much sales it has made, what are the revenue, what are the reviews, the ratings, whether customer is liking my product or not, and how can I make it better or whether to drop it altogether. So I can do a very good product analysis. I can come up with a brand new product, or I can come up with a renovative product. So these are all the crucial insights whether my product is accepted or rejected by the public. Another important application is competitor analysis. Of course, I can do it with various e-commerce sites. Which site is performing better and how can I improve upon it, right? Another is app development. Now, app development is important because you can really understand how this app system works. You can get information about weather, you can get information about the stores, the locations, you can get information about various historical sites nearby, where to dine in, where to have, where are they parking, are there restrooms. So you can just provide it in a consolidated form in an app, and this information can be derived through web scraping. So that's how you can make money through by developing app and launching it. Okay,
So this was it for this. So today's video is about web scraping in Python using Beautiful Soup. We'll go on to understanding first of all what is web scraping. So web scraping simply means that you want to obtain certain information, gather certain information from the web. By the way, this is the website wherein I will provide the link so that you can go ahead and see the theory part of it. So why do you need web scraping? It is just to analyze the data. You want to gather information faster. You want to find out the hidden trends, draw insight, and so on. So also for project work, we are doing web scraping. So if you want to find out whether it is legal to do web scraping or it is not legal, so there's one way to do that. After the site ends, you just append this robots.txt, which will tell you whether it allows scrapping or not. So I've just given it in here. So you just go and click this Flipkart robot and this thing, and you will find that what it has disallowed and what it has allowed. So my site is on WordPress, and this also does not allow web scraping and crawlers. Okay, but if you use follow certain rules which they provide, you might be able to scrap this site also. So this is what I found out, because it's good in protection, so you can trust WordPress on that. Okay, so now the examples for web scraping, I would say that it is used for like scrapping various tweets of Twitter on what is trending. You can scrap the reviews, ratings of Amazon, okay, and details about job openings, the portals. You can scrap the email IDs, and you can then send bunk emails on those, and you can spam, people, and you'll be blacklisted after that. Okay, fine. So now we walk on to web scraping. So now this is the things I've written. You can understand these things, the definitions and stuff. Now, how do you collect the data? How do you collect data from the internet? You've got tons of data, and you get everything here in the internet. So there are two ways to collect. First is APIs, and that is application programming interface. Now these are something which allow you to access the data in a predefined manner, and you don't have to really inspect the data. The process is very simple, but at times you do not have APIs, so you have to access that page in HTML format, hypertext markup language. This is not a programming language, guys, please. This is just a language, okay? And this is the way you just design a web page, and you visually present contents to the user using HTML, and CSS is adding certain styles to HTML page, and you use JavaScript and JSON in that for interaction with the users. So now I would come to web scraping. So there are various ways in Python wherein you can perform this web scraping, and in this video we'll be discussing Beautiful Soup. And then I am just in this publishing mode here. So you've got Beautiful Soup, Scrappy, Request, Selenium, and you've got LXML. These are the web scraping libraries available in Python, and as per your wish you can use any of these libraries, but I'm working with Beautiful Soup because of its added advantage that it is having an inbuilt encoding. That means I don't have to encode every time I pass a code in Python. So that's what you will read here. It has got automatically detect encoding and stuff. So, and it is very good to parse your XML and HTML file. And one more important thing here is that this Beautiful Soup libraries, it can parse what HTML parsing libraries like HTML5lib, LXML, HTML.parser. So in this project we'll be using this HTML.parser. Okay, so we'll start with the project, and I will show you one more thing before starting the project, is that this website. So don't worry about this thing. I'll tell you everything. So this is the website. The link will be provided. This is National Weather Service. Now, is it legal to scrap this website content? Yes, because it is in public domain. So I can inspect the data. So I have this my Jupyter notebook. If you do not have Beautiful Soup installed, please install it either in your Jupyter notebook by the command pip install bs4, or if you want its installation in your Anaconda command prompt, then just write conda install and just forge this Anaconda Beautiful Soup, okay, by this command. So I have this installed. So what I do is I simply import request. Now this is another library which would help me get this website, okay, just simply like downloading this website. So I will use request for that, and this get function will get this website, and from bs4 I will import this Beautiful Soup. All right, okay. Now what I am doing, just be with me and have patience, and we'll just rock this. Okay, so in an object called page, I will invoke this library, and I will tell it to get this page. Which page? This page. Okay, I will provide the link, don't worry. Now what I do is I create this object called soup, okay, and here it is Beautiful Soup. I invoke this Beautiful Soup library, and I tell it page.content. It will get all the contents of the page that will be downloaded, okay, and these will be the object of Beautiful Soup now, okay, every content. And I will use the HTML parser. So HTML parser will parse this entire page, okay, just like going through the entire page. That's what I'm telling it to do. Now the thing comes. Now this, if I want to tell you, this another object which is 7day. Okay, now let us now how to proceed this. You go to this extended forecast and right click on this. go to inspect, Control Shift plus I, inspect. Make sure you are on this elements, okay? And now when you click on this elements, first of all, there's a little understanding of HTML which is required here, which is a very simple syntax. Just like you can see head, when you scrollable body, you can see the body, you can see the main class, you can see the header, navigation, and you can see this tag as div. Now, I want you to specifically pay attention to this div. This is content area. I don't want this. What I want is, I want this today, tonight, Saturday. I want to retrieve this information. I will simply go down, more down, more down. Okay. You can see this ID, 7-day forecast. Just click on this. And you can see here that I'm getting this ID. And when I click over this, I hover over this, I can see this blue entire being highlighted. And this covers the entire San Francisco extended forecast, right? Classes panel. Now, if I close this, if you can see that the entire tags which are coming beneath this gets hidden. So that means that the 7-day forecast is coming under this tag. Now I want a class. I want to discover the class of this 7-day forecast so that I can retrieve the entire information. So how do I do that? See, simply just click on this, copy, and go to the copy element. Okay, you copy this element, you go to console, and here you just simply paste it. Got it? Okay. So I got everything here. Now, can you see this tag ID 7-day forecast and its class? Now, I wanted the class of this 7-day forecast list. And what is the class? This is the forecast tombstone. Can you find this list here? The class. Now, this li is called the list, item list. The item in the list is this forecast tombstone. Now, listen to this very carefully, that this is the parent element which must be contained, this class. That's why I was searching for this class, because this is the parent element that has to be contained. So now I'll be using this class. I will be using the 7-day forecast. Okay, let's get back to the code. Now I am using this. I've created an object called 7-day which will find the soup. Now I will invoke the soup.find what? 7-day forecast ID. Okay, this will find this 7-day forecast, whatever I give. And then in another forecast items, what I will give here is 7-day.find all what? Class tombstone container. So these objects, whatever I want, these items, they will be contained in this class, and I'm going to find them here from this class. Okay. Now I just want to retrieve a few information so as to show you. So what I do is I create an object called today. In that I give forecast items, and the container item element is 0, the list, and I just give it print tonight.prettify. Now Beautiful Soup uses this prettify to just print everything, the content I have in that function. So now I get this as an output. So you can see I got everything here. So this Beautiful Soup is using all the fancy names, right? Prettify, Beautiful Soup, and every stuff like that. So now you get the class as tombstone container. You get the class as the paragraph here, P. The period name is what? Today. Then you get here the image title here. This is today. Rain likely after 4 p.m. and blah, blah, blah. And then you come here. Then you get here class as short description. That is partly sunny. Then you find here another class which is temperature high, which is 57 degrees Celsius. So I found 3 things here of importance. That is the period name. Okay. I got the short description, which is partly sunny and then rain likely. Okay. And I got temperature. Now, remember one thing. I have just got an element of the first container. If I can just show you this one, the 01. Now, what if I want it for another containers, like this first element? So for the first element, what I get here, again, the class is the same, tombstone container. This is the parent class, which is very important. That's why I have given it here for all class. Now you can skim through all the days with this class. Okay, this will just help you and lead you to all the childs. So now this parent is leading me to the another child, which is in the first list, first item container, and that is tonight. Okay, the first in this list is tonight first, right? Now
Whatever description is there, I'm gonna read it. And as you can see, your temperature falling to near 51 by 9 p.m. and so on. Now let's understand this 2. What if I give here 2? So it will give me Saturday. Okay, so you can see here I get the class period name Saturday. I get the short description, chance rain, high temperature 61 degree Fahrenheit. So let's revert it back to tonight because the element resonates with this element. Okay, now this was the description of getting the entire text with the help of this code. Now what if I want to extract certain information or scrap certain information from the page? So I have shown you here when you were inspecting. Now remember here carefully that it is difficult with here to find the class and go ahead. Like here also you can find this class short description, but it will come after really inspecting it quite minutely. Where is this class, another class, and another class of temperature and so on. So if you just scrap it here, it is very easy to find the class of the various classes which have been defined under this parent class. Okay, so this is what the beauty of scraping is. Okay, so now I just scrape information from here again. Now we have seen periods, we have seen the period, that is today, tonight, etc. So what I do is I use the function called find. So today, from today object, I will find class period name dot get text. So it will get the text, and I will use the short description, and again create an object for short description just to extract specific information. Then again you can just write today dot find class and short description from that class, and dot get text temperature, create another object, and then you can just write today dot find class and then temperature dot get text. So you can print the period, short description, and temperature, and what you will get is this: partly sunny, then rain likely. And what is that? This was today. What if you write here tonight? Then you have to change everything here tonight. Okay, then you have to write here Saturday, Sunday, whatever description you want. The short description would be given instead of going through the entire description. Okay, just specific information. Now if you want to get the image, the title of it, so you can just write create an object image and then parse through this thing. So today dot find, and then you have image, another object here, beautiful soup object, and then you have this description. What is it? In this you will store this title, and you will get this title: today rain likely after 4 p.m, partly sunny with near 57, the high near 57, and so on. Okay, now what if I want to scrap all the information? I want to find out all the periods, I want to find out all the short description and temperature. Okay, we will do that now. So this is just for the first one, and then we will find out the rest. So what I did was, in the period tags, again you have this 7 day dot select. We created the object before, if you remember. Yes, okay, so we'll just do that. So we'll have this 7 day dot select, and what is the class? This is the container, Tombstone container dot period name. All right, periods is equals to what? Again, in list I will find, in this list I will use for loop so that I can get the name of all the periods. So pt dot get text for pt in period tags. So these period tags is what, as you can see, I got the list of all the period tags, that is today, tonight, Saturday, Saturday night, Sunday, Sunday night, Monday, Monday night, and Tuesday. Okay, all 9 I suppose. Yeah, so I'm going a little fast because I don't want to break the rhythm and momentum of it. Okay, slow down the speed if you want. So now I will let's just do it for short description, temperature, and descriptions. Okay, so again create do again just copy paste this same thing, but just change this object dot, that is sd dot get text, and for 7 days select, and just give the container class and dot short description. This will give you all the short descriptions. Then in temperature, again get text, and then run a for loop. For that it will get the temperature of entire list, okay, in a form of a list. And then you've got descriptions, wherein you can get the image descriptions here. So when you run this code, you will get something like this. Okay, this is the entire description of all these periods, and then you get the temperature. So like today it's 57 degrees Celsius, tonight it is low 51 degree Fahrenheit, I'm sorry, and then so on. Okay, and now if you have got this data, entire data, now you want to convert it into a data frame. So let's just convert it into data frame. Okay, so how do we convert this into a data frame? So, simple, by pandas. Okay, so pandas, import pandas as PD. In an object called weather, I will create this data frame in a form of, again, a dictionary. So I know I've got 4 columns here, which is period, short description, temperature, and descriptions. So I create it in the form of key and a value, and that is how I create the dictionary. And then I call this period, and this is how I get my data frame. So you can see here weather, and then you can find the weather.info, and weather.info looks something like this, that you have got some 9 objects in all these columns, and the data type is object. But before that, you'll have to change something here for this temperature. This becomes numeric rather than an object or a string. Also, you can find here like weather.shape if you want, and that is 9,4. So we have scrapped the 7-day forecast information into the simple format using Beautiful Soup in Python.
So hello friends, and today we shall be discussing about NLTK, and we'll be starting with NLTK. So first let us go to the download of how do you install NLTK. So if you're beginning for the first time, you go to your Anaconda command prompt, and in this Anaconda command prompt you have to write this command conda install -c Anaconda NLTK. And when you will write this command here, it will ask you yes or no whether to proceed or not. So you just press yes, and NLTK will be downloaded. I'm not doing it because I already have it. This download can take a few hours to a lot of hours because it takes time. It is a large collection of various corpora and data sets. So now we move on to where do you find this, where does it get installed, and everything I will be discussing. So first you open your Jupyter notebook, and this is my folder directory where I'm working. So I'll open a new Python 3 notebook, and here we shall start our NLP corpus. Okay, NLTK corpus. So this NLTK corpus, what is corpus? So first of all, what is corpus? Corpus, if I can say, is it is a plural form, and or I can say what is corpora. So corpora is singular, and pardon me for this. So this corpora is singular. It means it is a large body of linguistic data. So you've got various linguistic data, and it is a collection of that data. And when you've got multiple collection of this data, it becomes corpus. Okay. So one of the famous corpus is Gutenberg, and we'll be dealing with Gutenberg. We'll be dealing with Brown, Indian, and inaugural Indian, and I will show you 5 corpus how to load and start working on that. Few of them are listed here. So now I just convert this into raw, and let's start our importing of NLTK. So when your data has been downloaded, you can import this NLTK, and when it will be imported, what you have to write here is that the first command which you'll write here, that from NLTK.corpus you import Gutenberg. Okay, and I will tell you to just don't worry, just go with the flow, that what we are doing, just get the heck of it, how it looks here and how it is in your computer. I'll just tell you. And here we will write here file IDs, and we'll call this the Gutenberg file IDs. I have imported Gutenberg corpus from here. This corpus is again a collection of several texts which is from the Gutenberg press, and this is what we have got the text in Gutenberg like Austin Emma, Austin Precautions, Persuasion and Sense, Bible, Blake Poems. You've got Shakespeare, Macbeth, Hamlet, Caesar, Paradise, Milton, and so on. So these are the texts which we can explore, and we'll see how do we really process these things here. Now, if I tell you something about, if you also write here simply like Gutenberg, if you don't write here that print, so if I simply write here 5 IDs, and it will be giving me a list of all these text I have. Okay, so there's a difference between the format and how it has been represented. Next, I will come to showing you something which is very interesting, and what I'll write here is now I want to see where can I find this Gutenberg in my computer and where is it being stored. So what I write here is I can simply write here print Gutenberg, and this will give me the location where it is stored. So for me, it is in C drive, users, HP, app data, roaming, NLTK data, corpora, Gutenberg. So you see that it hides itself in some app data and roaming. So you have to explore it. Now, if you want to explore different data set or different corpora, then you have to mention that name of the corpora. So now I'll go to this location to see various corporas or corpus being located there. So I go here and I see here. Now you can see this data in Windows, users, HP, app data, roaming, NLTK data. I go to corpora. Now I also want to show you that in this NLTK data, you've got tokenizers, taggers, stemmers, sentiment, and so many things. So we can work with so much of data. So that's why it consumes a lot of memory. You go to corpora and you find a lot of corpora here to work with. These are the linguistic text which we work on. And here we have got some important, like here brown I was saying. You can just click on this brown and then see the file IDs here. It continues to CA and there are like 503 items here. Okay. Now when I move back, there are comparative sentences and Gutenberg, as you can see here. You've got Genesis, okay, in different languages. You've got Gutenberg in which we are working. So you can see here that we got all these text information in Python. We have called this that what are the text or what are the information here. So I got all these data here, right? Shakespeare, Hamlet, Caesar, Macbeth, and all. Now when I come to more corpora, more corpus, I would see here Indian, I'll see here inaugural. We'll be working with these two corpus also. And you've got movie review, you've got here one of the most important is like product reviews also are here. So you can work on these data sets, Shakespeare, sentiment, word sent, you've got stop words. We'll be discovering all these. A few important ones like WordNet, word text, and movie reviews and stuff. Okay, so for now let us just this is a basic thing, so I just shown you where it has been located. And here Indian, if you see, you've got various languages here, so we'll explore these languages also in our Python notebook. So this is where my NLTK gets downloaded, and this is how the data, the corpora, and what all the data I can access. Now I move on to finding out certain things. So let's just find here Caesar. Okay, I want to see what the Caesar has. So let's just write here. So I create an object called Caesar, and therein I write NLTK Corpus. This is how you have to call this, and you write here from where. This is the Gutenberg corpus, and I want the words in what. Just copy this words in this Shakespeare Caesar.text. How many words are there in this text? So I can just get the number of words in Shakespeare Caesar, and then I will write here length of Caesar. How long is this? This is like around 2500, more than 2500 words here you have got. Okay, and if you want to print the, like suppose the length of again I will, from what corpus you want. I want Gutenberg, so I'll write here Gutenberg corpus, and what I want dot words, you can write dot sentences, and here I will write, let's explore a different data set now, and let's take Macbeth. Okay, Shakespeare Macbeth dot h text. Okay, and I want to find the length of this, and close. Okay, so you find the length of this, and you find something around like 2300 words are there. Okay, so next thing I come to is a different thing. Now suppose I want sentences. I told you about sentences. So we have got a data set here called, a text here in Gutenberg, which is white man leaves. So I'll take this white man leaves, and now I will do something with this. So I'll write here white man, and in this white man underscore sentences, because I want to type the sentences here, equals to from which corpora I want this. I want this from Gutenberg, and what do I want? I want the sentences. So I write as sentences, and then I just copy paste this text Whitman, sorry, it's Whitman leaves, and then I just call this Whitman underscore sentences. Okay, and so you can see the sentences, and in here you should note that the spaces are also being counted here in the sentences. It is giving me commas also. It is just counting these colons also, these hyphens also. Everything is being counted, and they are giving me the sentences here. Okay, so you see Leaves of Grass by Walt Whitman 1855, comes that, and all these things are here in this text. So I can get an idea of what all data or linguistic things, verbs, phrases are there in this text. Okay, so this was about Gutenberg. Now we come to Brown dataset. I have told you this. Now we work with Brown corpus, and again I will write here from NLTK dot corpus. What I will do is I will import Brown. Okay, and when you import this, then you will write here Brown dot categories. Okay, so you can see the categories in Brown. So there are different genre here, different categories here, like adventure, you've got ballets, editorial, fiction, government, hobbies, learned, mystery, news, religion, review, romance, etc. So these are the categories, and it is very interesting corpora to explore, because you would find what all are the things which are being frequently used in these corpora. So let's just find out a few things here. If I can just zoom in. Okay, so now I will just tell you on to write. Let's just find something with romance. Okay, so like romance underscore text, I will write here from where do I want this from corpora brown dot, and I want the words from this. What words I want from the category. From what categories I want it from? Okay, romance, you can write here reviews, religion. Okay, we can write religion also, but okay, fine, let's just do this. So now I want the frequency distribution of how many words are there. So I'll write frequency distribution, and then NLTK dot, just give this command frequency distribution, and I will write here w dot lower, and I'll create a for loop so that I can get all the list of the frequency, all the words which are there in this romance underscore text, which are the object I have created. So it will just iterate and let me know this. Now I will create something called models, and in that I will write here, I will create a list here. So I will just because I don't know what is there in this text, so in romance I will just write simply there's a boy, there's a girl, there's love, and I can say there's could, maybe there's could, wish, or some words which you can just think of, right? Wish, or I can just write there's passion, and What else is there? Okay, let's just write here boy, girl. I can write here hot. Okay, we can just use this word. And if it is like smile or happy, something like that, or let me just write here world. Okay, getting all those things right. So now see, these are the words which I don't know, I'm just guessing it. Okay, so just because of the word romance is there, so I'm thinking like maybe these things are there. So for M in model, I'm just writing this in this object. I would like to print this M, and I will concatenate it with the okay, and this will just please give me, and I will write here frequency distribution, and in this you give me this the names which I have given you for these words, and in the end I will also give it an end, and I'll give it with a space because you will see the difference if not giving the space and giving the space. So here I go and print this. Okay, got 2 arrows. So now you can see that I've got this love something like 36 times this frequency distribution is coming. Boys 39, girls 26, code is 195. Okay, wish 22, passion is like 5, hot is coming repeated 15 times, smile like 11 times, world is coming 26 times. So this is the frequency distribution of these words in this romance text from the Brown corpus, right? Similarly, you can experiment with this religion, and you can write here like instead of romance, you can write experiment here with religion. Let's see, just for the practice sake, you can also do that. And here for like I'll leave it the same, and here you can write here boy, girl, could wish. Okay, and I can just replace here like God. I'll write here blessing, or here I will write here me, like might, could, etc. And let's see what we get. So like here you've got may, might, could, God is used 136 times, blessings, to, smile, world. You can see here like let's just also write here child. We are the children of God. Child too. Okay, so it is like this is how you can explore the data. This was about Brown. Now I also want to show you about a different data set, and that is now coming to that is okay, Reuters. Okay, now you've got this Reuters. So this data set, or this corpus, I'm sorry, this corpus, now we will again do the same thing from NLTK dot corpus. What I want, I import these Reuters. Okay, and in this Reuters dot file, yes, file IDs. What are the file IDs here? So I'll get so many of them. See, you get it in the form of test, and it just continues. It's so long, so I can just write the categories of these routers, and these are overlapping corpus. I'll just explain you what do you mean by this. There are various categories of corpus also which we are working with. So these are the categories which we will get. Now you can see the categories of this. You've got like ship, silver, sugar, yen, zinc, and so on. So there are a lot of categories here. Now I want to show you something from this text corpus structure, how it has been structured. Now you see that the simplest kind, it lacks any kind of structure. This is just an isolated text, and it is just a collection of text that you can see in Gutenberg web text. These are the examples of this, and we've explored Gutenberg. It is quite easy text corpus to deal with. And when you come with categorize, that is Brown, which we have seen here, the Brown data set. And in Brown we have seen various genre, like genre, that is fiction, government, hobbies, and etc. So this is kind of an organized or categorized corpus. Now this root word is something what is overlapping. So this becomes a little difficult to, complex to fetch this data set, this corpus. So this is rooters, and you've got inaugural, which we will see next, and that is temporal with time. So you've got various dates and years here in this temporal. So these are the different types of text corpus structures. Isolated is done, categorized is done, overlapping is done. Now we'll deal with temporal. Okay. So this was about the categories, routers, and now we come to a different corpus, and let's just explore a different corpus of I said temporal, right? So temporal would be inaugural because you have this from, I've shown you previously also. Again, you will write NLTK dot corpus import. What you will import inaugural, right? Inaugural, and then you will just in this inaugural dot file IDs, right here file IDs, and then you can just see the speeches of various American president, US presidents from like dating back to 1789 from Washington till Obama, Barack, no, it's still Trump 2017. So this is a text of all the inaugural speeches made by the US presidents. Okay, so I'll show you something interesting here. Let's just plot the number of times the citizens and the nation they have used in their speeches. So for what I'll do is, this is the frequency which I'm using, conditional frequency distribution, and here it is NLTK dot, there is N. Okay, so here you've got NLTK dot conditional frequency distribution. Okay, and in this what I will do is I will write here target, and actually this also has to be here, and okay, so I will write here target, and I will write here file IDs, and okay, so this is what I will give here for, and I close this because now what I'll do is I'll write here for file, I'll make a loop here for file ID in inaugural. Okay, in my this data set, and inaugural, what I will do is I will simply write here file IDs, and again for now what I want here, I want to make like for W in, let me just write it and then I will explain you this thing. Inaugural, okay, inaugural dot words, and then I have got here file ID, where am I? Yes, and then again for target, see this is, I'm making it for this, the target and file IDs, I'm making two loops here, for loops, and this, the target I'm giving is, they have to say it America, and they have to say citizens. I want just to know how many times they are saying the American and citizens in their speeches. Different presidents have used this thing, and then I will write if W dot lower, and then I will write here dot starts with target, starts with target, and then I will close this bracket, and then what I do is I will just simply plot it. I will write here cfd dot plot. Let's see what it gives us. Fingers crossed. Target file IDs, and then I have got here for file ID in this inaugural file IDs. I want to retrieve how many times American and citizens have been used by various presidents during their speeches, inaugural speeches. So that is what I write here. Okay, but I have made here file ID, and here is file ID IDs. Okay, and you can write here like if you don't want to give your file ID, you can write here only file also. It depends upon you, but okay, let's see. So it's just plotting the data, and the matplotlib acts as its use. So now you can see that over the course of years, like here 2017, the America has been used like around 35, more than 35 this thing counts. And previous presidents used to use the citizens a lot of time, and especially in the span of like around 1840s, and so you've got citizens so much. And here now the nation gets more prominence, America, and you can associate yourself with America if you're an American citizen. And you know, people tend to like those speeches. So you can see the trend that it is increasing so much. During Trump times it has just shooted, but not here with the citizen. It has just not been used so frequently now. Okay, so this is how you can just see the graph. This is just a way. Now I will explore you one more data set which is just for fun, and this is really very interesting. And that is an Indian data set. If I told you about the Indian corpora, and let's just talk about Indian corpora. So what I do is from NLTK again, I would import this. Okay, so what I do is from, what is this? Okay, so from NLTK dot corpus, what I'll do is I will import again Indian. This is the corpora I want, and then I will write here Indian dot file IDs, and just see, you've got Bangla.pos, Indian.pos, Hindi and Marathi and Telugu. Now what you do is, I want to see what all words are there in this Indian words corpus, especially Hindi. So I'll just write here dot words, and this is dot, okay, dot words, Indian words, and here it is Hindi dot. Now since I got the name, I can write here Hindi.pos and just hit click enter. So you get this Hindi like Poon Pratibandh Hatao. You've got these colons also, and then Iraq, Sanyukt, and so on. Now if you want to change this to like Bangla, so you get this, like, I don't know how to read this, Omar, Amar, I don't know. And then you can write here Telugu, okay, I can just read this for and this period. And similarly, you can just also explore this Marathi, since this is a small corpus, so not much this thing. So you can just read this Va, Samaj, etc. And if you just want to check the length of, suppose, the Bangla.pos, it'll give you 10. If you want to check about Hindi, it is 9. So these are only 9 something words here. So that is what you're getting here. Okay. So this was about the different type of corpus which we have seen: isolated, categorized, overlapping, literal, and temporal, which was inaugural. And I'll provide the link here in the description box to go through this data set, this corpora, and this it's a very good NLTK.org book. This is chapter 2 of this, wherein they have explored all these data sets. And these are the words, these are the examples which we can use to import and see, explore our corpora. So we have used file IDs, we have used categories. Raw is something which also includes all your spaces also. It is not giving your data without spaces. So that is raw, which we'll use later. Sentences, words we have used. Here you can specify the words of specific fields here. Because if you don't want words of the entire corpora, you just want it for specific fields, so just specify that. Sentences, okay, then encoding also, if you know the encoding of the file, what it is, UTB-8 or something. And root is like where it is located, and readme if you want to read the contents. So this is about the NLTK corpora and its different type, and how do you really work with these files, get into Python and start exploring these data sets. So in the next tutorial, we will explore more about it, like stop word stemming, lemmatizing, and so on. So stay tuned, guys, and thanks for watching. So today we shall discuss about stemming and lemmatization in NLTK.
And how do we perform this? Along with various examples. So let's just start with the practical session. And I have renamed this Python 3.0 with stemming, and we start with first importing. So what you write is simply import NLTK, and if it is not downloaded, then you have to write NLTK.download. Mine has already been downloaded in C folder app data roaming. It goes and store itself, so you have to find it out. And the link will be provided in the description box so that you can understand how to go about this with the first tutorial. So now first let us understand. I will walk you through two lemmatization stemmer techniques, and that will be Porter stemmer and Lancaster stemmer, right? So Lancaster stemming and Porter stemming. So what are these two? Okay, converted into third heading. Now from NLTK, first of all, let's just import this package, right? And then we can understand the meaning of it better once it is here in front of us. So NLTK.stem, because in the stem you've got all these packages stored, we will get this Porter stemmer, right? And again, I'll create an object called Porter, or you can create any object, and in that you store this, right? And after this, what I do is I'll call this Porter.stem. I'll create this thing, and let's write a word in what you have to stem. So I will write here an interesting word called spirituality. Okay, and let's see how Porter stemmer works here. So you just run this and you find this is spirit and you. Okay, you is also coming here. So this is what Porter stemmer works. So I'll walk you through this article, this blog which I have written. It says that stemming just reduces the word or the related words into to their root. And this does not necessarily mean that it will convey any meaning, but it just breaks down the entire word into their root, right? This is how the stemming works. Now, if you want, now there are various ways or various stemming algorithms which are used in Python to stem the words. And these algorithms, they use various stemmers like English stemmer. For English language, it is Porter stemmer, Lancaster stemmer. And for non-English languages, it is called snowball stemmer. So we'll see the various languages which this snowball stemmer really supports. And for Arabic language, you've got ISRI stemmer, and for Portuguese language also you've got one stemmer, right? So when you go through this entire this thing, you will understand what is Porter stemmer and its various advantages. So this is quite fast, and this is the oldest stemmer, 1960s. Sometimes it came. Now let's come to Lancaster stemmer and how does it work. So I've already from NLTK.stem, I have to import this, import the Lancaster, okay, Lancaster stemmer, right? And then create an object called any object you can name that. I'll just name that stemmer itself, and just write here Lancaster stemmer, right? And now you call this. So I will write here Lancaster.stem. What? Again the same word. So I'll write again the same word here, and let's see how does this stemmer works. Okay. So when you will run this, you will find here spirit. So can you find the difference between the two, Porter stemmer and Lancaster stemmer? Lancaster stemmer is giving me some meaning out of this word rather than just stemming it. So this is what stemming and different stemmer, how do they work. Now I'll walk you through another example here, and that is like, now you can use it. Now you can simply write use with various examples, like, so you can just write, sorry for the disturbance, and now it was like Porter.stem, and then you can write here like friendship, right? So you can just write friendship and see what does this stem. Friendship. Okay, what if I do here friendships? S has been eliminated and it has been routed to friendship. What about Lancaster stemmer? So I will write here Lancaster.stem. Again, the same word I can write here so that we can just simply map the difference between the two, and that is friend. Now you can see the difference. Okay, so Lancaster is much more making more sense as compared to the Potter stemmer, because it works like iteratively. So the working, if you want to go to the working of it, what happens is that it just works iteratively, and the algorithm, what it does, it tries to find with the help of some rules, and it maps the last character of the word, okay, last character of the word, and maps it through rule. And if suppose there is no rule, then it has been terminated. So the disadvantage is that because of this iteration, there's heavy load and there's heavy stemming. And so when you've got this heavy stemming, what happens is that sometimes you may get no meaning or non-lingual stemming, right? Stem words. So now what I'm trying to say is, now let's understand, this was just word stemming. Now what if you have to do some sentence stemming? So let's just go and see some sentences being. So let's just see the sentences stemming. Okay, how do we do this sentence stemming? So given a sentence, suppose I have a sentence, so I'll just copy the sentence from here so that it is faster. I have written this sentence, and the sentence is like, life can be challenging, tiring, but the challenges lead to transformation. I run this, and then I simply use Potter.stem, and simple right here, Potter.stem, and I'm using Potter stemmer here. Now can you see, I just get the same sentence back. It is not being stemmed. What to do now? You have to make define a function for this, and you have to use both sentence and word tokenizer so that this just runs perfectly, and each word in the sentence is being tokenized, or it is being stemmed, right? So I will use this sentence tokenizer from NLTK. So from NLTK, if you've downloaded, we are using all the packages from NLTK. So it is important that you download it first, right? And it is in the first tutorial of NLTK. Link is provided, and the video will also be shared. You can find it on the end screen. And so what happens here is that you define a function called stem sentence, right? In that you pass any sentence which you're having, and then in token words, you have this tokenized word tokenizer, and then you create another a list of stem sentence, and then run a for loop for that. And when you will run this, you will find this being stemmed. Okay, so how you can see this is can be life can be, as you can say, it is challenging has been removed to challenge, and it is not e also here, tired, but the challenge lead to transformation. Now if you want to use here Lancaster stemmer, just change into Lancaster. Okay, and then run this, and now can you see this is just the same? I don't think that this is the same. There is a difference, so that can be seen here when I will show you both the stemmers simultaneously. So just write here Potters.stem, and okay, so tire, tir, and a little difference, right, in stemming. So this was about sentence stemming. Now we shall come to stop words. I want to show you, okay, before that let me show you something like snowball stemmer. How many languages does it support? So let's just see this snowball stemmer. And again, from nltk.download, what I'll do is again I have to call this nltk.stem. What you do is import this snowball stemmer. Okay, this is capital snow, this is not capital, snowball stemmer. And then what you do is, since I have to see all the languages that they support, so I will simply call .stemmer.languages just to get an idea of how many languages that they support. So you can see here
French, German, Italian, Norway, Portuguese, Russian, Spanish, Swedish, and so on. Okay. Now I will show you something called stop words. Okay. So this is just an addition, just because simple stop words. So what are stop words in NLTK? So I will simply write here stop words, or you can just write stop, and then from NLTK.corpus. Now this is in the package corpus of NLTK, and from there I am downloading or importing all these stop words, and these stop words have to be in English. Okay. So what are all these stop words in English? I will simply print this stop. So lazy corpus object loader not callable. Okay. Dot stop words. I think you have to write here dot words also, and then you can go ahead and print this stop. Okay, my mistake. Yeah. So can you see this? These are the stop words, which means that these are not so significant in our text, and we can simply do away with these words like I, me, myself, we, are, ourselves, you, that, do, this, while, until, because they consume a lot of space in our text, and even if they are not there, we can understand the meaning of the sentences. So now if you want to play around with this, just right here print, and if you want to see the length of these stop words, so just write stop and you will get 179. Okay, now coming to the next part of it, and that is called lemmatizers. So what are these lemmatizers? Now this is something really interesting, and it becomes very important when you really have to have the meaning of the sentences in terms of the context. Okay, so context meaning or contextual meaning, if you are concerned with, then go for this lemmatizer. Otherwise we use stemming because it is fast and it's quick. Actually, sometimes meaning of the words doesn't matter. So I'm using here from NLTK stem. Again, you import what? WordNet stemmer. Make sure that WordNet is being downloaded here, and okay, WordNet lemmatizer. Now one thing is that you can lemmatize with various approaches and techniques, but here I'm using WordNet lemmatizer, and you run this. Now I'll walk you through various lemmatizers also. So here you have got lemmatizer, and in that we will store this. Okay, WordNet lemmatizer. Okay, so what I do is I will just simply go and copy what I have done before, and I'll show you the difference. What does this do really? And this is really interesting because it preserves the part of speech of sentences. So you do this, what I'm writing is here, first word I'm using is swimming, and then I will use this lemmatizer dot lemmatize swimming, and POS, I'm using this POS as verb. The part of speech I'm using is as verb. In the second one I'm not using any, that means by default it is. So by default this is noun. Okay, and a denotes adjective here, that is I'm using better for this. Now when you run this, what you will get, you'll get something like, for swimming this has been converted to a verb called swim, and this corpora is being converted to corpus, which is noun by default, since I have not mentioned anything. Had I mentioned here, I'll do that later, but first understand this adjective as better is being converted to an adjective form of it, and that is good. Now suppose if you just write here best, and here what I'm doing is I am giving a pause, part of speech, and suppose let's take here adjective. What does it give me? Okay, not supporting, not supporting. So here for the best also, again you've got good here. What was the problem here? I just need to find this out. What if I do this verb? Invalid for print. Okay, I need to close this. By default is a noun. So I have to use noun here, lemmatization, and okay, it is giving me good corpora, corpus, plural and singular form. So this was about this lemmatizing. You can change the word here, cycling, it will come cycle, reading, it will come read, depending on the part of speech you are giving, whether it is verb, adjective, or adverb, any part of speech. So now I'm walking you through various types of lemmatizing techniques or approach through which you can lemmatize. So there are roughly like 10 here, but there are many. So we have used this wordnet with part of speech tag. There's wordnet, there's text blob, and then again text blob with POS. You have got Spacey, you've got tree tagger, pattern, Gensim is there, Stanford Core, NLP is there. So these are the lemmatizers wherein you can really derive the meaning of the entire text depending upon its context. So the meaning is not lost. So this is the applications. If you want to go through the applications of stemming and lemmatization, mainly it is for text mining, for sentiment analysis, for document clustering so that you understand the entire document without losing its meaning. Okay. Various algorithms, Google, Amazon, so many online websites use stemming and lemmatizing for their day-to-day applications. So now which stemmer to use, what to use, whether stemmers are to be used or lemmatizers. So it depends upon the task, it depends upon your work, your need. So you use stemmers when you really want good and fast results because speed is the focus, then you use stemmers. But when the meaning of the word is to be preserved in relation to the context, because sometimes two words are being used differently in various sentences, so you have to preserve that authenticity, that originality of the sentences, so we have to use lemmatizers. So this is where you use lemmatizer, and when meaning is not important, then we can use stemmers. So these are the references and sources which you can follow to have greater in-depth understanding of the same, right? So hello friends and welcome back, and today we shall be doing analysis of sentiment analysis of the food reviews, and this is the data set of Kaggle Amazon Fine Food Reviews, and this can be downloaded from here. I'll provide the link, and you can just go and hit the download button, unzip the file, and we'll get started with our Jupyter notebook. So this is the current my directory which I'm working on, and I have uploaded this reviews.csv here. So I just need this file here, and then I will start with the Amazon Fine Food Review analysis. So let me just show you what are we gonna do in this. Now, first of all, what is sentiment analysis? It is simply analyzing an opinion of people, whether it is positive, negative, or neutral regarding any service, product, or food. So this time we are dealing with food, okay? And this shows the attitude of a speaker, all right? Now we start with loading basic libraries. I think by now you people are like well versed and expert in loading NumPy, Pandas, Matplotlib, and also Seaborn here. I have now downloaded Seaborn here. Okay, so which I'll show you later on, okay, because it has been imported in the later cells. So next we will just read the CSV file in our df container which we have created an object. Read the first 5. What does it shows? It just shows me ID, product ID, user ID, profile name, and so on. Now what is the important thing here? Either I can drop the things which I don't need, the columns, or I can simply carry on with the data and use only the columns which are needed. So I have not dropped, but I have carried on with the data set. So I have used the score, summary, text. Okay, so these are of more importance here: the score, the summary, and the text, which would help me determine all right, which would help me determine the sentiment of the user about the product, about the food. All right, so let's see the shape of this data. It is like more than 5 lakh reviews, and there are 10 columns, as you can see. And if we go on to the info, this is simple exploration of the data set which we are doing. And you can see the data types and you can see the null type. So we have got certain null values in the profile name, in summary, and also in the score. No, not in the score, but in profile name and in summary only, right? And you can see the data type here. So I will not invest more time in here. Okay. Now let me first show you the DF summary, because we are concerned with summary and head. So I will show you the, let's see the summary dot head. What does it show? This is like okay, I've converted into a data frame, and this is like good quality dog food, not as advertised, and you can see the first 5 entries here. Next is, you can see similarly the first 5 texts. What does this contains is that I have brought several of this, etc, etc. Now you see, notice one thing in this text. I have got I've got is, if, you, at, so these are the stop words, and I can remove them. Okay, and you can also see that these are capital letters. So next task comes from this, that we have to do some text processing. So what is this text processing? Is that you're removing these stop words, you're converting it into a lowercase, you're removing punctuation if any, and you are lemmatizing them. Lemmatizing, as we have done in the earlier video, that lemmatizing simply, it just makes this word to its root. It just takes it to its root, and also takes care of the context. So you can just refer to the previous videos. I will provide the link and everything. So just for now, let's just be on the same page. So this is text processing. Now for text pre-processing, I'm using text blob. Now this is also a library which is very easy and easy to use, and it interfaces well with NLTK library, and it is also built upon NLTK. And this helps us to perform various functions like, tagging. You can, do some extraction from this, sentiment analysis, classification, translation. It is also used for uh, calculating the sentiment scores. But we won't be using text block for this video, in this project especially. So what, first of all, is that you have to install this text block. So this is the command in the command line. In this Jupyter notebook, just write pip install text block. So when this will be installed, we can just get started with this. So now, NLTK Corpus, I hope you've got NLTK downloaded, and this will work when you've got NLTK downloaded. So import NLTK and download NLTK. It is in the previous first video, the basic video. Please go and watch it, because this is important. How does this corpus work, and what all are there in the corpus? So in this NLTK corpus, we will import stop words, and then from text blob we will import text blob and also word. Now the first pre-processing is with lower casing and removing the punctuation. So this is how we'll remove this. We will apply lambda function here. This is an anonymous function in Python. And then what we do is simply we are replacing it with with a space, and then join this x lower for x dot x dot x and x dot split. This is what the function we are using. X dot split is important here, and what is that which is being replaced? And that is that it is being replaced by this simple lower casing. Okay, right. So now the next is removing the punctuation. I want to remove these punctuations, like these punctuations which have been mentioned here. This will also parse the underscores and everything, and this is being replaced by a simple space, or simple I can say it's a space, right? So as you can see here, you will find here I is being replaced by lowercase. Every first sentence, first word is being alphabet is being replaced by lowercase, and the punctuations have also been replaced. Let's just see first how this replace works. Actually, the syntax for this is str.replace, that is string.replace old, new, and count. So if you got a string like, yo, the food was delicious, and you would just replace it like print string.replace what, the word old delicious with yummy. So what you get is that, yo, the food was yummy. So this is how the replace function work. Okay, all right. So now we go on to removing these stop words. So you'll remove these stop words like, stop is equals to stop words dot word. Now I'm using these words of text blob, remember. So text blob helped me to remove these things. So the stop word, I'm dealing with the English language, so I've used English. And then what I do is I will again split it and join it, removing the stop words and joining it again. So that's what it has been done. So you can see that I, me, my, is, everything has been removed. These stop words are being removed. Okay. So I have not run this spelling correction code because this was taking a lot of time, and this really takes a lot of time because there are like 5 lakh reviews. So you have to be a little bit patient and let it run. Now we'll use lemmatization. In lemmatization, again, I will use apply lambda function here. Lambda is very useful when you're applying all these things. So you can just quickly code it in just one line and done with it. So word dot word and then lemmatize for x dot x, for x and x dot split, and then you can see that it has been lemmatized. Okay, now I want to show you something about word cloud. So we are now using the word cloud. Moving to word cloud, what is this word cloud is? First let me show you this word cloud so that it gives you a better understanding of it. So this is what word clouds look like, and we have to plot this. Now this is something called like a visual representation of the words which are occurring frequently or uh, in the data in our text. So these are the most prominent words in the text. So what we'll do is we will plot this for the summary. Okay, so we'll look at the summary text using the word cloud. So word cloud, again, it is a visual representation, and the importance of each bean is shown with the font size or color. And this is very, you can very quickly perceive the most prominent terms in this just for visual representation, how what our you know our text data really contains. It's a good way. So first of all, you have to install this word cloud, and when you will install this, you will get something like this. So I'm working on this version. Okay, so now you will import the word cloud, import the stop words, and then now we cannot just simply go ahead and plot this. First let us do a little exploration first. So first I will show you this df.score value counts, because we will be using scores in our reviews. Okay, so the score, like we've got some 5 scores, 1 to 5, and you can see that the 5, the positive one, is the highest. We have something like 3 lakh something or so, and the negative scores are, the negative reviews are also there, but we have got mostly the positive reviews, as you can see in the count plot also. 4 and 5, that means they are positive reviews we have, and 1 2 are the negative reviews. 3 means neutral. So we'll be working with positive and negative only. So let's what do I do? I just create a new data frame called reviews, and I store it like, and perform further exploratory analysis in this. So reviews, we've got a few, drop any, that means any null values, I will just drop it. And then what you do is, in object called score 1 till score 5, just to store these. What if reviews score equals to 1, review score equals to 2, and so on. So this is gonna store all these things. Next thing what I'll do it, I will just concatenate all the above score 1 till 5, and I will, what I'll do, I'll use this now later on in my code. So I've just used this. Now what I'll do is I will create the word cloud for this summaries this thing column. So what I do is that word cloud function, it just has to take a single string. Actually, it will not take the string for so many like we have got in here. So we have to convert it into a single string of text, and for that I have to concatenate all the summaries. That's what we have done it here. Now you can build it for text column. What you do have to do is, like, here's summary, just write text. Okay, so that's how you can interchange it with text column, and you will get the words, prominent words, for the text column. So now what I do is, in reviews.str, this is an object which has been created, and here I'm using this review sample, which is a single string of all the concatenated reviews here, and I will just take the summary of it, and then I will use the function str.cat, and then just word plot this, make a, again, an object word cloud. I'm defining the background as white. You can take black, gray, anything, and then you dot generate what, review str, this object. Okay, set the figure size, set set the internal im dot show what you want, interpolation as bilinear, and the word cloud, and the x's you can just set it, and plt dot show to show you the graph, the plot which you've got. And as you can see that the great, good, taste, best, love, product, and all these things, these are the words which are prominent in my summary column. And if you just convert it to text, you will get another set of words which would be for the text column. Okay, followed? Now we come to something different. Now again for further analysis, because now we want positive and negative reviews. Similar like word, this word cloud for positive and negative reviews. Let's just create that. So before that we create, what we do is we will create an object for negative and positive reviews, and that's what has been done here. So we have splitted the data into negative and positive scores. Scores is 1 and 2, it is negative, and positive is 4 and 5, right? Okay, so this is what I have written. So if you've got a score as 1 and 2, then this is a negative review, and if it is 4 and 5, then it is positive review. Then we have transformed everything into a single string, and what we use for that is str.cat. Okay, this function, and that is what we have done. We have done negative reviews dot summary dot str.cat, positive reviews dot summary str.cat. Okay, since we are using it for summary, that's why I have used summary here. Otherwise you can use text if you're using text here. Okay, now what you do is, now we'll create a word cloud for negative reviews and positive reviews. So this is I have firstly, you just set the background color as white and black, anything as per your choice. So this is white for the negative reviews, and you generate what negative review string. That is what we have created here, the single string, this object. And for positive again, you just set the background color as black and generate positive review string, this one, right? So again, set the figure size for Matplotlib, and it will just show you. I've set the title, figure size, plot, and everything. So this is what it looks like. Review with negative scores. So as you can see here, what are the reviews? Taste, bad, worth, dog, mad, made, disappointed, chocolate, hard, awful. Can you see these things? Bitter, one. But you can see also here great, good, everything. So there's a mix of things. Okay, you can see horrible. So this is just a way to get a vague idea about what all words are there in your summary or your text, right? Beware, expensive, worst smell. Can you see? Okay. Now we come to the reviews with the positive scores. Again, just we are just setting the figure size and giving the various parameters for that. And this you can see: best, great, good, love, excellent, delicious, tasty, taste, free, flavor, product, etc. Okay, happy, perfect. Okay. Now we are coming to, now we are done with the word cloud. Now let's come to the sentiment score. What does the sentiment score means? This means that you are using, actually in this project we are using a pre-trained model, and it takes input from the text and output the sentiment score, which could be from -1 to 1. If you do not understand this thing, it will be very clear. Just follow with me, just be with me. Okay, so now we are using the Weather sentiment here, and this is Valence Aware Dictionary and Sentiment Reasoner. This is the library which we will be using. So you have to install this first. This will might take a little time, but when you're done with this, we will start using it. So this, what does this do? This helps you to estimate the positive and negative score. This tells you about the positive and negative score, but also it tells you the how much it is. Like, it tells you the intensity of the positive and negative score. Also it gives you the value of it. So if you want to know, just not knowing positive and negative, but also how much positive and how much negative, so this is what the sentiment score is. So that is what we will be calculating with better sentiment, and we are using a pre-trained model. We don't have to design a model for this. Okay, all right, so this is polarity, actually -1 and +1, which also the text blob uses. So you can either use text blob here, or you can use this better sentiment. So we are using better sentiment. After installation, let us just so I've imported Cbon here. All right. So what you do is import all these libraries. This is for regular expression, OS system, and all these things. Now I'm using this function to get these sentiments. So what is that? From Veda sentiment dot Veda sentiment import in sentiment intensity analyzer. This will help you in getting these scores. And then in analyzer, I've stored this analyzer. Then what you do is you generate sentiment for all the sentences which are present in the dataset, because that is what is required here. Because what the sentence is saying, it is having an emotion or a sentiment behind it, and we want to understand that sentiment. So how do we understand this? This is the code which helps you to determine that. So you create an empty array, and then we will go for a for loop here in the text, and then you create this vs, and here we will use the polarity score here in those row, and you will append this. Then what you will do, you will create a new data frame with the sentiments, and the new data frame would contain these elements, as you can see here: the negative, neutral, positive, and the compound. Now, as you can see here, the compound, now I'll tell you what this compound means. But before that, this data frame has to be concatenated with our initial data frame. So what I do is I concat this and I just reset this index, and you concat this df sentiments here. Axis is 1 for the columns. So as you can see, this has been concatenated with our initial data frame. So we got this negative, neutral, positive compound. But how would you understand which review is positive and negative? It is just the numbers which is saying certain things. So now to make it more user friendly, more readable, what we do is we will simply use a threshold function, and we will convert the positive and negative sentiments using that threshold. So what I'll do is if just a condition that if the compound, this compound what we got, if it is greater than equal to 0, then it is positive, else it is negative, right? So when we run this code, what happens is that we get here the sentiment as positive because it is greater than equals to 0, and it is negative when it is less than equal to 0, sorry, less than 0, right? So this is how it just gives you the sentiment of each text, okay, the review. Now the result is what? Now if you want to just sum up the result, that how many positive and how many negative reviews we have, so you can just make an object result, and then store this dfc sentiment dot value comes, and you will plot it and give it a good color, like any color you want. So this is positive and negative, and we see that the positive reviews are much higher, like more than 5 lakh as compared to the negative reviews. So you can just interchange this sentiment with different I mean to say that you can just group by this sentiment to buy products, and to understand how the customers giving the feedback against the product. So you can just explore various columns here and plot them. So this was about Amazon food find review analysis. Another thing is that this is also if you are worried about how to get this coding sheet, then don't worry, because it will be provided in the GitHub link and also on this Kaggle sheet. You can just go to the kernel and download it or work with it. So code is not a problem, just understanding how does it work and what is word cloud and why we are using this. And I hope this better sentiment is clear to you guys, and if you've got any problem, please post it in the comment section so that I can just work on that. And this was the sentiment analysis of the food reviews, right? And stay tuned for next upcoming videos and projects, and thanks for watching.
Series analysis in Python. So today it is the basic tutorial getting started with time series analysis, and the complete exploration of the dataset will be in Python. So let's first understand what is time series analysis. So this time series, you can say this is a statistical technique and which deals with data in series of a particular time interval or any period. So to put it simply, it means that I am analyzing certain previous values to predict the future value. And this is how I make analysis. Now this can be a trend analysis, seasonal analysis, or cyclic fluctuation analysis. And how is it different from time series forecasting? Time series analysis is simply you are analyzing by way of plotting or analyzing the trends. But in time series forecasting, what happens is you are making a model, you are predicting things, and we are using various algorithms here, like time series algorithm, which make things really easy for us, like autoregressive moving average or autoregressive integrated, moving average. So there are a few examples of this time series analysis, like wind speed, power prediction, stock market prediction, weather prediction. And in today's video, we shall be discussing about stock market prediction. And the data set we will be working with is the TCS data set. And from where we will get this data, I will just explain you in a short while. Let me first tell you that the components of time series analysis is trend component, wherein we analyze the movement of various, I would say, up and down, or the fluctuation which a product or some stock or share prices show over a period of time, right?
Then seasonality, that means as per season how the fluctuation is really affecting the service, the stock or weather. Another is cyclic component. Now this is like when you've got some business or economic boom or bust cycle, that is cycle, it follows a certain pattern. And you've got random component also. So these are the components of time series, and you can just go through for further details by clicking this link here. And as you can see that this is the like cyclic, it just follows a trend, ups and downs, and the seasonal means depending on the season, right? So now why is it important to study this time series analysis? Everything changes with respect to time, and when you have to map the changes, you have to understand how this data is really changing with respect to time, and you need to analyze this over a long period to better understand the data. So you understand the changes, you understand how these changes have impacted the scenario, and based on this analysis you make some crucial insights and improve the decisions, make business decisions. So in this video we will be discussing about TCS share prices, and we will be analyzing it on our Jupyter notebook. So coming to the data set, where will you get the data set? This is a Kaggle site of Rohan Rao, and he has uploaded the dataset. So you download the dataset from here, and when you will download it, you will get some, like in a zip folder, some 52 files in CSV. And here you can see, like, you can explore any file taking this as a reference, TCS as a reference, right? So we will take this TCS file, this, as you can see here, tcs.csv, ITC, and 22 more. So they are like Asian Paints, Bajaj Finance, Britannia, Gale, and so on. So what you do is, when you are done with your downloading, you extract those files, and in my Jupyter directory, I will go to my, this is the current directory I'm working with, and this is the Python notebook I've created, Basic Time Series Forecasting Analysis. Actually, this is not forecasting, this is analysis, because I am not making any model. So this is analysis. Okay. So how do I start this with? We will simply start with importing basic libraries, and this is a very basic fundamental tutorial to get you started with time series analysis. So start with importing your pandas, matplotlib for plotting, cmon for plotting, and matplotlib.dates as mdates. Now this will be important, and I will show you how this really affects us. Then we go on to reading the file, and here we see that df is equals to, in a data called df container, I will store this file, entire CSV file, and you can see how does this data look like. So in the shape, I will see I've got some like more than 3970 like 70 rows and 15 columns. As you can see, these columns like date, symbol, series, and so on. Now what is more important here is open, high, low, last, close, VWAP. We will explore what this VWAP means, volume, turnover, and so on. So when you see this info of this data set, we find that the above three are object, that means they are string, and rest is in like different integers, I mean in numbers, float and integers. Now remember this thing, that date here is treated as an object or a string, but when we have to do analysis in time series, this date has to be converted into a date time with the help of pandas. So that is what we will do now. And if you want to see like how from the date, the minimum and the maximum date of this data set, so we write simply here print df.date.min, that will give me the minimum date, and that is like 2004, 25th August 2004, and the maximum date is 31st August 2020. So we have a data set spread across 16 years ranging from 2004 to 2020. Okay, so now let's get started with something called an important feature here, which is VWAP, and this is volume weighted average price. Now what does this mean, volume weighted average price? This is the benchmark and very important variable here in this data set, because this not only tells me the price but also the volume. And if you want to know more about this, I have provided the link here so that you can just go through what does this mean, VWAP. So when you click on this link, you will find here the formula for this. That is, it is sigma price into volume divided by sigma volume. And this is very important benchmark which traders really map, because this gives you an estimate of price and volume, right? So when you plot this, this is also the target variable. If we do the forecasting, we will have to predict these VWAP, right? So when you plot this, you can see this trend, this line. And don't worry about the code. I will provide the link of GitHub so that you can access the entire notebook. So just understand how do you really plot and what does this, how does it make sense. So I'm just plotting it. As you can see here, this is the prices, okay, of the shares of stock. And here, as you can see, but one thing I will tell you here is that we are not able to see which year, which trend, was there a rise, was there a low. We are not able to understand that thing. It is just simply plotting the average prices right here. So you can see here that here was the highest price 3500, here was the lowest. In fact, the lowest was here, like less than 500 also. So we'll see from which year was this data, this fluctuation was resulting, and which period does this really happened, right? So this is what we will analyze further. This is a simple plot, and now we will move on to creating a new data set. Actually, we've got some 15 rows, 15 columns, which we don't want. We don't want these turnover trades and so on. So what we'll do is, for our convenience, we will create one simple data set, a simple data frame. And here we will, in the data, we will take only selective columns. So we have taken date, open, close, high, low, and this VWAP and volume. Okay. And when you see this data set, you will find something like this. Now again, remember here, date is an object. It is a string. It is not treated as a date time. So if you want to explore it further, we have to convert it into date time. So how we apply this? We will use pandas date time function. So simply in this date, what you do is apply pd dot to date time. And when you will apply this pd dot to date time, it will be converted to date time, and we will convert this date into index so that it can parse through various rows and columns. Now, when I set this to index, this is how it will look like. Okay, this has been set to index, and then we've got our remaining 6 columns. Okay. Now, I'll come to the data visualization part of it as to how the kernel density estimation looks like. And you see that here is a fluctuation. And you see that there's a boom and there's low, boom and low. And that is what happens in stock prices, bullish and bearish market. Now, since TCS is the second largest, market share in India after Reliance in terms of market capitalization, we will study further as to how has it really been impacted because of this corona crisis, this coronavirus, the pandemic. And this is what my focus is here, to understand with each month and each date. So let me introduce you to one more thing in this pandas, and that is subsetting. What does this subsetting means? That I'm creating a further subset of my data, right? And I use what I can do, I can slice the time series data so that I can highlight a certain portion of it I'm interested. And the most important part is WMAP, which I'm interested in. And so I will take this further for my analysis, right? So what I do is I again create a data frame called df underscore VWAP. And then in that I create date and VMAP. I just want these 2 columns of further investigation, and then you see really how we can do it. Again, I will make this date as index. I will apply it to date time so that I can convert it into date time, as you can see, and convert this into index. This is how our data set looks like then. Now I have just 2 columns here. Okay. And now when you plot this VMAP here on this matplotlib axis, you will find something like this. Now can you see the dates, the year, and how is it different from the previous one? There's a contrast. When I have plotted simply using VMAP and I have simply plotted this, it showed me something like this without giving me any year on x-axis. But to make it more sensible, it is better to plot it like this, so that I get on my x-axis dates, so that I can map it that, okay, like in 2008, the share prices were very low, below 500. And in like around 2016 and 17, there was a boom. It was more than 3,000. So what happened that there was a boom. These best practices need to be adopted, and these certain other factors which impacted the low shares, the low price of the TCS. What were these factors? We can go in deep with this trend analysis. Okay. So now this is the plot size. As you can see, this is a simple plot with dates here. So that makes more sense. Now to make more sense of my data set, what I want is, I can see here that this 2018, something happened that the stock prices were a real low. It just came down to 1500 and so from 3500. So let me explore this further. We'll zoom in the year 2018 to see what really happened. Okay. So what we do is, again, I will plot each month for the year 2018. So this is a simple analysis, and in an object I will say AX. I will plot this. I will use 2018 as a year, and I will use this column I have, that is weighted volume average prices, right? Volume weighted average prices, and set the title. I've just given a different color so that it becomes a little fine to understand. And on x-axis, Y label is again our prices. So now you can see the year and the month. So this is January, this is again March, May, July, August, September. This is how we can just read this. And you see that the bump just happened in the month of July, as you can see here, right? After July it happened. And then it was all-time low, right? As compared to January and till May, right? And then from like third quarter, second quarter, it was just low. So this is how you can just go deep into this month-wise analysis. Again, you can just go on little further, as to, like, you can see here that again I have gone a little further in this. Like, I have explored this May to June further analysis to break it into dates also even further. And this is what I realized, that yes, it should be like from 2018 May to 2018, May to June. That is what I want, May June trend analysis. So again, set the title, set Y label, and now what I'm doing is this. I'm using matplotlib M dates, and I'm using the weekday locator. This weekday locator would be a day from which it will start. So like from Monday to Monday. So like 7th, you can say, is Monday, 14th is Monday, and like a gap of 7 days, Monday. So it will locate every Monday and it will plot it. Okay, so what was the price on Monday, then next Monday, next week, and so on. This is how it is being plotted. And so this is how I am going into a particular year. In that particular year, months, and in that month again I am further investigating and analyzing that data. Now I there's a little more interesting thing, that this corona, how did it really impacted the shares of TCS. So what I did was, I just did this month-wise trend analysis for 2020. So instead of 2018, let's just analyze what happened to the shares in 2020. So again, you plot the same thing. Don't worry about the code you can get anywhere, guys. Just understand the analysis of it. What happens here, that if I can just zoom in this thing, so you just see this, that I've taken the location as 2020, and you can see the column here. Set the plot size and give any color, and you set the title, set the y-axis. Now this M dates, what you do is you go to month locator. It will locate the month of 2020 and it will plot it on the x-axis here. So it will plot what? January, February, and you can see here that it was a lockdown in India on March 20th of March. So if I'm not wrong, the share price also started impacting. It was affected in the month of March, and it was all-time low here in the mid of March, and then it slowly slowly it took a little increase, and then again it was down in April. So you can see the investor sentiment and the stock prices in fluctuation because of this pandemic, right? So this is how you can make analysis of this, that yes, there was an outbreak, there was lockdown, and so how the share prices were really impacted. But gradually we were adjusting with corona, and now it has become a part of our life. So now we have really, now this can be seen in this trend, that the economy is now, the share prices are again increasing, and economy is recovering, though not at fast pace, but yes, it is. As you can see, the share prices are again investing, and market sentiments are bullish. So here we can see that yes, we have got some good news here. So share prices again increased to like more than 2000, which is a good news. So in September you can map it as like around 2000, and so from all time low when pandemic just hit us, and now we are like, yes, dealing with it head on. So this is what the month wise trend analysis. Now if you want to go a little further, what happened to March to May, then again you can just go in a little further for that March to May trend analysis, only taking 2 months in specific. So just to see this, how it really impacted, on what date was the lowest price. As you can see here, like May 20th, when the lockdown hit, you can see the prices really were down. So the external factors also impact in a major way these share prices. So they are not just the investor sentiment, but also other shocking pandemic or global or financial instability, international scenarios, national instability, everything impacts this thing. So there are various factors influencing the share prices, and so we see that in the March, somewhere around 28th of March, we have low prices. Then again it was high up, and then again it was low, and so we see this is what happens in stock prices, low, up, down. But we do not expect a large decline or a very large increase. It's fine, but bearish market is really a worry for the economy. So now this is how you plot, and again we are just analyzing from month of March till May, and the days we have taken as Monday, start of every month, right? Okay. So now this is another thing. Now I will use the reset function. Now let me tell you about the reset function. Reset function in pandas, what it does. So now let us understand this reset. Okay. So as you've seen that we are working with only two columns, that is date and vmap. Now what I do is I will extract from the date year, month, day of week, and weekday name. Okay, so this is a very interesting feature wherein I will simply extract so many features from simple date, and then again I will set this index as date, and now you see this data frame how it looks like. This is how I have done. From date I have extracted year, I have extracted date, I have extracted month, day of the week, and weekday name from a simple code that the pandas have to offer. Okay, so this is pandas is really very helpful in time series analysis, especially for time series analysis. I will say this is really a big blessing. So now what we do is we just have got these extra columns here. Okay, and now this will make our time resampling very easy. Okay, so now we are on to the time resampling. So this is just a theory which you can find it here also. I have written it here, so you can go to this website and see what all features does. So we are just focusing on how to really resample things according to year or quarter or month. So this resampling thing, what it looks like, I will show you something interesting here. Okay, so in the pandas documentation you will find something like this. Okay, and these are the codes, or these are the values, offset values which we can use. So I have used here like weekly frequency, month end frequency, and the quarter end frequency. Okay, so what it does is really I have resample, I've used this dot resample, and rule I have taken as A. This means year end resampling. and dot mean. Now I am using a function here, aggregate function called mean. Why am I using mean here? I have got a data set, and analyzing just 1 day data, 1 day prices will not make any sense. I want to make sense of this entire data, TCS share prices, so that I can invest in this. And I want to see that whether it is giving me a good return, whether the market is bearish or bullish, what was the closing price, what the price it offers, and will my money be well spent. So what happens here is that I want to get an idea for TCS, how is it performing for the past, say, 10 years or 5 years or so, and then I can make a sound decision, and that is what I'm doing now. So years resampling I will use. Every year, like 2004, 5, 6, as you can see here, just 5 I have seen here, I'm seeing here. I want to see the average prices and the volume of the TCS share. So for the year 2004 and the last month and the last date, so the closing date, I will say, what was the share price? So as you can see, it was like 1038, 1300, and so 1400 and so on. So this was about the aggregate, the mean of that entire year. This will give me an estimate as to how the shares are performing. Now if I plot it, this is how it will look like. So you can see that it is well within the range of above 1000, 1500, and now shooting to like more than 2000, more than 2500, right? Except certain years like this, when we had faced in 2008 till 10 the global financial crisis because of the crash of Lehman Brothers, and then we can see that this prices are really low, and our Indian economy suffered the ripple effects of it, and it could be seen in the stock market prices. Here it was less than 500 or so. The US market just went down, Lehman Brothers crashed, you can say bubble burst. They lended to even the non-lenders, non-credit worthy people, and so it just crashed. So then it just recovered, and we learned our lessons well, and the decisions were made accordingly, and so the prices were good. So this is how you can make an analysis whether to invest in TCS or in some other firm or not, by the trend analysis. How is it really performing in the year end, right? If you want to understand the weekly frequency, again, just use the rule like W. We've got it in Pandas, just you have to apply it. And you can see like weekly, what is the mean. And you can see the weeks here. For the year 2004, every week, every 7th day, you will find the mean. It is 900. Now, so it is increasing every week, as you can see here, right? But it is not true for other years also. It might not hold true. Monthly, simply, you can also see the monthly frequency with the rule M. So just experiment with different rules. What data does it give you? How it really plots. You can just see it with this plot, which makes life much easier, Okay. Now coming to another thing, you can also use the standard deviation, like what is the spread, but not of that use. Mean aggregation is the thing which you want to see here. This is the quarter frequency if you want to see how in each quarter is it performing. So this is what you can do. Now, coming to the shift function. This video might be a little long. Please bear with me, because this is the basic thing which we'll use in our further projects, which will come like in the next week or so on Wednesday. So this is very important because I'll be using these things. So just get a little familiar with the shift, the rolling window and stuff. So now this is what our original data looked like. VWAP resample, not this one actually. This is a data set, okay? The year, month, day of week, and weekday. Now I will be showing you what does this shift, forward shift, and backward shift means. Now, if you simply go by the term, it means it is shifting the data forward, and backward means it is shifting the data backward, okay? Now, how does it does this? You simply write this, take your data frame and dot shift function of pandas and dot head. Now, what happens here is that you see this data and you compare this with this data. If I can just zoom in and just I show you this first data set here. It is 1800.32, right? And the month is 2004. You see this here 1800.32 and month 2004. It has just shifted one forward. Okay, if you can see this, it has been shifted one place forward, so this has been shifting one place, and it has to be +1, and if you add here -1, this would be a backward shift. So for backward shift, what will happen? It will shift one place higher, and since there was no data above this, so this is like filled with not an integer, because there was nothing to fill on this, right? Now backward shift, what will happen? You will simply write here dot shift -1 dot head, and when you will call this, you will find here something like this from the original data set. I close this, and from the original data set, what you will find is this will be shifted above. Okay, this will be shifted above, again above, one above, minus, and here when it was forward, it was one below, and there was nothing to fill here, so this was left empty. Had it been like here 2004-08 24th of August, it would have filled that day, right? But the first column would be, first row would be empty because you don't have anything to fill. So now this was backward and forward shift. This is how I can shift, I can fill my data, okay, and I can analyze what was the closing and the opening date of that this thing, that month, year, or the date. Okay, now I'm coming to the rolling window. I'm going a little fast because this has a lot to offer. So now you come to the rolling window, and you can just study this thing. Okay, so rolling window means that simply you can just understand that this is the moving average, and what you do is you apply this window like with function like mean, median, and count depending on your need. And this is very useful because what does this do is like it will smooth out the data, it will reduce the noise of your data. Okay, and we will see this, how does it really do this. What we do is we can simply use this rolling, and I'm using it for a week. Let's take a mean of 7 days, right, and just print the first 10 entries of this data. I'm using the data set data frame which has been created as df_vmap, this vwap dot rolling, and I use the mean of 7 days, and this is what it looks like. Now you see, I am not getting any value being filled with the first 6 days because there was not enough data to calculate the mean for these 6 days. Okay, so I am not getting anything here, but when I got enough data to be calculated, I got the value starting from 2nd of the month 9th and the year 2004. Okay, right? Now you can see this data, right? So you can see it from 2nd September 2004, your data started to fill in, and we get the mean of it. This is the rolling window, and I'll show you something in this plot. So this is just a theory which has been written, which you can find in this blog also. So what happens here is that this I will plot simply the VMAP first of all. So this blue line, as you can see, is a simple plot without any rolling window or average, and you can see that this fluctuation, these lines, so much of this is called the noise in the data, and I want to avoid this, so I will smoothen out this data and I will reduce the noise, and this can be done through rolling average. That is what I'm doing. And now I apply this rolling and I take the window as 30. You can increase the window, but 30 is more precise, right, standard. And then I will apply the mean of what VWAP and plot it, and what we get here is this, and this has been smoothened out, this has been reduced. See, the orange line, as you can see, is without noise, this is smoothened, and this is the rolling average, as compared to the blue line, which is the original price data, but it is having a lot of noise, right? So this is used in this time series analysis so that we get more predictable analysis, more predictable trend of how the shares are performing over the years, and this is what the rolling window help us to do. So if you want to read more about rolling window, I have provided the link here for rolling window of Wikipedia, and what is this moving average and how has it been really helpful in time series analysis.